Okay, good morning, everybody. Welcome back to the session with 360DigiTMG. So yesterday we have started discussing about an interesting tool which is RapidMiner. So let's just quickly have a recap of this. So yesterday, what did we see? So we have seen yesterday. Okay, we have seen yesterday about RapidMiner. So before talking about that, RapidMiner is a no-code development platform. So why this is a no-code development platform? It is useful for data mining purpose. So we have seen what is data mining and what is no-code development platform. And we have also seen what is RapidMiner and where we will use this RapidMiner, few advantages, disadvantages, and also we have seen how to download and install and set up this RapidMiner. We have seen all of these in yesterday's session. And also we have seen what is the interface, how does the interface of RapidMiner looks like, and also what are the important features, like there is a rich operator toolbox present, drag and drop interface present. All of these are the features. And interface, which is GUI, it consists of few important components, like what? Yesterday we have seen these things, components like operators and process, help, repository, all of these things are present. Along with that, we have different views like design, results, auto model, and also turbo prep. So these are the components or the interface of a RapidMiner, which we have seen yesterday. And yesterday, we have also started discussing about EDA, which is nothing but exploratory data analytics. So within this, we have seen first moment business decision and second moment business decision. So first moment business decision consists of mean, median, and mode. And second moment business decision consists of variance, standard deviation, and range. And also we have seen expected value. So let's continue with yesterday's session. Let me clear these things. Okay, so what did we see in yesterday's session? Let's just see in the PPT itself. So introduction of RapidMiner and RapidMiner download and installation, features and inbuilt data present in RapidMiner, and also how to import external data. So what is data mining? We will just talk about this not in brief manner, just a single point. So data mining is used for analyzing large amount of data in order to uncover patterns and insights to make informed decisions and also to improve the organization or businesses according to their aspects of the operations. That is data mining. And also there are few tasks present like estimation, forecasting, classification, clustering, and association. And also no-code development platform. What are these no-code development platforms? These are the software tools which provides us drag and drop interface without writing the code. So these, some of the examples of this, one of the example that we have discussed is RapidMiner. So RapidMiner, it is a comprehensive data science platform with a visual workflow design and full automation. It is used for business purpose, commercial purpose, research purpose, education purpose, and a lot of different uses are there. And then we have seen what are the different products present. So RapidMiner Studio, RapidMiner Go, RapidMiner Auto Model, and Server. And also along with that, we have Turbo Prep, Hadoop, and AI Hub is present. So these are the different products within which we have downloaded and installed one of the product, which is RapidMiner Studio, within which we have Auto Model and Turbo Prep incorporated. And we have seen few advantages of RapidMiner and advantages versus disadvantages. And also where do we use RapidMiner in industries? And also, what kind of data set RapidMiner can process? Like it can process or import structured data. Like what is structured data? Which is present in the form of rows and columns. Like what? CSV files, Excel files, anything is a structured data. And it can also process unstructured data. Unstructured data consists of text, images, audio files, and also social media posts, emails. These all comes under unstructured data, which does not have any proper model. And it also supports other file formats like JSON, XML, etc. And also we can just work with databases or NoSQL systems. And it can also import data from cloud storage services like Dropbox and Google Drive. And we have seen how to download. So these are the various steps involved in downloading RapidMiner Studio. After downloading, we have to install the application. So how to install? And then we have to set up RapidMiner account. So how do we have to do? Each and every step we have discussed yesterday. Like once this downloading, installation, and setting up is done, this is the window of your RapidMiner. So you can see the tutorials on the left-hand side, which will come if you are beginner for this particular tool, you can just go through these tutorials. And then we have seen features, as I told, it consists of rich operator toolbox and also drag and drop interface, and it can integrate with multiple data sources, and also automated machine learning is present. And even if you are working with large amount of data, this is not making that to slow down, that is scalability. And also it is used to deploy predictive models. So these are the important features. And coming to the interface, we have repository, operators, parameters, views, and in the views, we have different views. Design view, where we will do everything like each and everything drag and dropping and connections, everything happens under the design view. So this is the primary workspace where users design and build their data analytics processes. And results view, in the results view, once the process that you have created is executed, the results can be seen in results view. So not only the results, we can also see statistics and also visualizations. We have seen this yesterday itself. And auto model view, in auto model view, we can just model the feature, this feature automates the process of building predictive models. Like you have to specify your target variable and you have to give your settings, your input variables. And according to that, you have to select what models you want. And within that, the best one will get selected. And turbo prep is used to clean, transform, and manipulate the data efficiently. So these are the 4 views present. And at last, we have process and help. These are the various components or how the interface of DataMiner consists of. And then data. So coming to the data in RapidMiner, we have inbuilt sample data present, which is present under repository panel within the samples folder. So we have seen how to use inbuilt data and also how to import external data. So external data is nothing but the data which is not inbuiltly or defaultly present within the application, which is RapidMiner Studio. So we are using some other data sources present in our local machine, and we are importing that into this particular tool, and we are doing whatever we want, whether analysis or we want to create the visualizations or the modeling, anything that you do once you import the data that you want, or you can use the inbuilt data also. And also we have seen how to load data, which is a CSV file. So there are 2 ways in which one way the data will get permanently stored in a particular repository that you select, which can be used for future purpose. So in the second way, it is just for temporary purpose. You can just use it for that particular process, and later on you can't see it in your RapidMiner Studio. So this is what we have seen. And coming to the next one, we have covered yesterday the first moment of business decision and second moment of business decision. So what is first moment and what is second moment? So once we will go to the mind map and we'll look at the mind map, we'll get the idea. So here, if you observe, these are the various steps involved in a project management methodology. So first of all, before moving on to EDA or data preparation, you have to go to business understanding. So under the business understanding, you will have business problem, business objective, business constraint, and also different success criteria. So different success criteria are present. Yesterday, I gave you an example for this as well. And also when you are writing the business objective or a business constraint, you have to write within 2 to 3 words. And you have to use the optimization terms, minimize or maximize. So this all comes under business understanding. After the completion of business understanding, you have to go to data understanding. So what is data understanding? So what are the columns present in your data? What are the data types of every column? You have to understand. So data types may be different types. It may be continuous, it may be discrete, it may be structured, unstructured, it may be qualitative, or it may be quantitative, it may be big data, it is balanced, or anything. So we have to learn about the data types. And also, when we are collecting the data, you are collecting from the primary data sources or secondary data sources. What is primary and what is secondary? You have to get an idea about the data collection as well. This comes under data understanding. After you're done with business understanding and the data understanding, you have to move on to the third one, which is data preparation. So under the data preparation, again, we have a few, which is exploratory data analysis, which is EDA. It is also called as descriptive statistics. So yesterday we have started discussing about this. Before starting discussing about this, we have also seen what is probability and what is a random variable and what is probability distribution and inferential statistics. We have covered these also in yesterday's session. And also we have seen the first moment of business decision, which is measures of central tendency. So this includes mean, median, and mode. And we didn't see all of these things. Let us see this today. So in the first moment of business decision, we have measures of central tendency. We have mean, median, or mode. So mean is also called as average. As we have told, mean is getting influenced by the outliers. We have seen this in the form of an example in Excel sheet yesterday. So when we have an outlier present in our data, so based on the data, whether we have outliers or not, it will affect the measure of central tendency mean. So when you have outliers in your data, always prefer median. So median is not influenced by outliers. So median, what is median? It is the middlemost value of the data set. If you have like huge number of records, how can you calculate the middlemost value? So you have to first, when you use median function or anything, you will just, it will sort the data accordingly in the backend. You won't do the sorting and all. It will sort the data and it will find the middlemost value and it will give you the output. That is median. So measures of central tendency, which is the first moment business decisions, which consist of mean. Mean is also called as average, and mean gets influenced by outliers. And coming to the second one, median. So when you have outliers in your data, you should always go for median instead of mean. Why? Because even though outliers are present in your data, median is not getting influenced by outliers. Okay. And then mode, you already know whatever the value that is repeating mostly, which for suppose if you are working with categorical data, this we have talked about yesterday. Let us see one more time and we'll move on. Okay. So what we are talking about. Okay. So when we have categorical data, sorry. Okay. So when we have categorical data present, so what is categorical data? So categorical data, like yesterday we have seen if you have numerical data and categorical data. So numerical data like 1, 2, 3, 4, and 5 is present. So for this data, I can calculate average, which is mean, and I can calculate median, which is the middlemost value. But if I want to calculate mode, how can I calculate? And also, if you have categorical data, like the sales are low sales is present, medium sales is present, or moderate sales is present, and high sales is present. So when you have different categorical data present like this, so how can you calculate mean, median for this particular data? How can you calculate? So when you have categorical data, okay. So when you have categorical data, we always go for mode. So what is mode? Mode is the most repeated value. When you have categorical data like low sales, moderate sales, and high sales, we will always go for mode instead of mean and median because we can't calculate mean and median for categorical data. So this is one point. Okay. So mean is clear, median is clear, and mode is fine. So mode, what is mode? So mode is the value which is repeating maximum times. And mode, if it is a single mode, it is called unimodal. If two values are getting repeated three times, then that is two modes. We are having two modes that is called as bimodal. And if we have more than two modes, that is called multimodal. And more modes implies the presence of clusters. So this is about the first moment of business decisions. Okay, when you have categorical data, you have to go for mode instead of mean and median. And also when you have outliers in your data, you should go for median. because median will not get influenced with outliers, where mean will get influenced by outliers. And coming to the second moment of business decisions, these are called as measures of dispersion. So coming to the measures of dispersion, we have again variance, standard deviation, and range. So what is this variance? So variance. So variance, we have already seen yesterday. Variance is nothing but, how can we talk about variance? So variance is the difference between the squared differences between, we can say it as the squared differences between, yesterday I've shown you the example and the calculation as well, squared differences between each and every value with the mean. Squared differences between each and every value with mean is called as variance. So disadvantage, what is the disadvantage? That the units are getting squared. That is the disadvantage. So squared differences between each value with the mean is called as variance. Is called as variance. So what is the disadvantage in variance? In variance, the disadvantage is the units are getting squared. And what about the next one? The next one, we have standard deviation. Standard deviation, we have the square root of variance is called standard deviation. And then advantage is that we get back our original inputs from squared units. So what is standard deviation? Standard deviation is square root of variance. So because we are making the square root, so if even the differences are squared, we are not losing our input data. We are again performing the square root over here. We will get the original values back. That is the advantage of standard deviation. And the last one that we have is range. So range is nothing but the difference between maximum and minimum. The range is difference between maximum and minimum. So these comes under measures of dispersion. So we have seen yesterday measures of central tendency, measures of dispersion. Now let's talk about the remaining things. Okay, let's talk about the remaining things. So let me open this one. Okay, if you observe over here, everybody, now we are going to talk about the business movements, remaining business movements, that is third business movement and fourth one. Okay, fourth, first movement of business decision or everything, first one is measures of central tendency, measures of dispersion is done. We'll look at the other two present in the mind map, that is third movement business decision and fourth movement. And we will also look after the graphical representation. Okay, so let us go through this module. Okay, in this, we are going to discuss about the introduction to graphical representation, bar plot, histogram, third movement business decision, fourth movement business decision, and box plot, normal distribution, QQ plot, and scatter plot. We are going to discuss about all of these things in this particular module. So let's go to the first sheet or first slide here. So here, this slide is talking about a particular graphical representation, which is bar plot. So you already know about bar plot. So what is bar plot, everybody? So bar plot, we can just call it as, okay, what can we call? So bar plot, we can call it as univariate plot. You can call it as univariate plot. Okay, univariate is nothing but the word uni means one. The word uni means one. So when you are about to plot a chart for a single variable, when you are about to chart for a single variable, when you are about to plot using a single variable, you can go for univariate charts. So where can you see this univariate charts? I will show you in the mind map also. So when you go back to the mind map over here, here under the graphical representations, you have univariate. So what is univariate? So univariate consists of all these different charts which are useful to plot a chart or create the visualization using a single variable. So within this, we are discussing about the bar plot. So let's see what is present in the bar plot in that particular example. So coming to this example that we have, so as I told, bar plot is, okay, sorry. Bar plot is a univariate plot. Okay, bar plot is univariate plot. And what else? And what else? What else? So here in the screenshot provided below, you can see a bar plot plotted across x-axis and y-axis. So you have X and you have Y. So what is this X and what is Y? So imagine this is about, or this is based on the data set education, which everybody already have, I guess. So here, when you are plotting this chart based on education data set, on X-axis, imagine, so what we have, just make it a slideshow. Just a second. Okay. Okay, let me create here. Okay, fine. Okay, so we are about to talk about this bar chart presented here. So imagine this bar chart. In this bar chart, we have X and we have Y. And imagine X is plotted with the help of the series numbers or serial numbers of students. Just an example, okay? So imagine this is serial number of students. The X-axis consists of serial number of students and Y-axis is consisting of GMAT scores. So here you can see, here you can see this one, which is 0, 200, 400, and 600, which are plotted against y-axis. This, imagine it as GMAT scores. So when you see this particular bar chart, when you observe this particular plot, which is bar plot, this is not very clear. This is clumsy and cluttered because why we are having these many these many bars coming over here in this particular bar plot. Why? Because when you have a lot of records present in your data. For suppose, imagine the education data set consists of around 700 to 800 records. So every like individual record is represented in the form of a bar. So when you have a lot of records, this particular bar plot is looking very clumsy because of that, or it is cluttered as well. So we can't draw any information from this particular plot. Why do we create visualizations? We will create visualizations to to get some meaningful insights from the particular plot. So from this particular bar plot that I have created over here, based on education data sets, taking serial number of students on x-axis and GMAT on y-axis, I'm not getting any meaningful information. So I can get only 1 point like what? So most of the bars are above 600, which means most of the students are scoring the GMAT scores, which is greater than 600. That is the only thing that I can understand from this particular bar plot. But what about the other things? What about the other things? Can I understand any other thing from this particular bar plot? No. Why? Because of having a lot of records in my data set, when I am creating a bar plot, which is a univariate plot, I am getting individual bar for individual record. So this is making the bar plot looking clumsy and cluttered. Because of this, we can't gain much information from this bar plot. So now, what should we do if we have such kind of things? We can go for some other chart, which is called as histogram. So before going to the histogram, let us open our RapidMiner and let us see how to create this bar plot in RapidMiner. Okay, let me open RapidMiner. Just give it a second. So yesterday we have already downloaded this RapidMiner Studio. I'm opening the same application that we have seen yesterday. Just give it a second. Okay. So yesterday we have downloaded this application and we have seen installation process and all, and we have worked on few of things yesterday, right? So I'm opening the same application, which is RapidMiner Studio, and I'm going to create a bar plot using the education data set, which is present in my local machine. I'm going to use that data set I'm going to create. This it is opening. Okay, let us see the education data set in the meantime. So I'm going to work with this particular data set that I've told you the example in that particular bar plot screenshot shown. So I'm going to work with this Excel sheet. Okay. Okay, this is taking some time. Okay, let us continue with the topic and I'll okay, this is starting normally. Okay, let us start discussing about the other things present in the PPT, and I will just show you how to create these later because this is creating some issue right now. Okay, fine. Let us go back to the PPT. Okay, so we have discussed bar plot. Now, as I told, I can't draw much information from this bar plot. Now, what is the other option that I have? I can go for the next thing, which is I can go for the next chart, which is histogram. So what is histogram? Everybody, what is histogram? So let us see how to create the charts in RapidMiner later. I'll show you every chart that we are discussing about. So histogram. So coming to the histogram, everything is opening very lately. Okay, sorry. Okay, so we are discussing about histogram. Histogram is also another univariate plot. So as we talked about univariate is nothing but whichever the chart or plot or visualizations that we can create using a single variable, those are coming under univariate plots. Those comes under univariate plots. Okay, then what is this? Again, whatever is present, histogram is also called as frequency distribution. So what is frequency distribution? We'll see. So whenever we are plotting a histogram, this is called frequency distribution. Always on x-axis, we have random variable. We have discussed what is random variable yesterday. A variable we have like a variable which is having variable possible values. And also there is a chance of each and every event or possible value to occur randomly, that is called random variable. So when we are plotting a histogram, always the random variable will be on x-axis and frequency will be on y-axis. That is why this is called as frequency distribution. Okay, so histogram is a univariate chart or univariate plot, and histogram is called as frequency distribution. Why? Because when we are plotting a histogram, on x-axis we will have random variable, on y-axis we will have frequency. And also, while we are creating a histogram, automatically it will create bins. So bins are also called as buckets. Buckets are also called as groups. So when we are plotting a histogram, automatically it will create bins. Bins is also called as buckets. Buckets is also called as groups. Now let's see the example provided here. Okay. Sorry. Okay. So in this first example, in this particular histogram, if you can see, on x-axis we have random variable, on y-axis we have frequency. And also, when we are plotting a histogram, this is just looking like this. Okay. We will see the second one also, and I'll show you the example. Okay. Okay. If you see this particular histogram over here, when I just plot a curve over this curve is like this. Okay, sorry. So when I just draw a curve for these data points present in the histogram, I got the curve like this. So what is this curve? So I'll just erase this part. So how this curve is showing. So what is this curve talks about? So histogram also talks about the distribution of data, whether the data distribution is normal or not normal. So when you have a histogram like this, if you see, there is a small tail present over here. This is called a small tail or extension. So apart from this, the distribution of the other data is normal. What is this? When we look at this histogram, always on x-axis, we will have random variable. On y-axis, we will have frequency. So when we look at this particular histogram, on left side, we have a small tail or extension present. Apart from that, the data is normal. So what do you mean by normal? So we have the distribution of data, which is symmetrical across the mean. So this is the mean, imagine. So right side and left side will be equal, mostly. That is called as normal distribution. And coming to the second one, we have here density plot. So density plot is also a univariate plot. This is also useful for one variable, and this is called as probability distribution. So this histogram is called as frequency distribution. This one is called as probability distribution. When we are plotting a density plot, on x-axis, we will have random variable. On y-axis, we will have density or probability. Okay, the only difference present between histogram and density plot is that on y-axis, for histogram, this is frequency. For density plot, it is density or probability. Apart from that, everything else is same. The chart, how it looks, everything else is same. So we have discussed how many univariate plots up to now. We have seen bar plot. If we are not drawing meaningful information from this bar plot, we can go for another charts like histogram and also density plot. Anything is fine. So these are about the basic univariate charts present. We'll discuss few more others later. Okay, now we'll see the next slide. What is present? Why we have discussed about these univariate plots before discussing about the third moment and fourth moment business decisions, I'll tell you. Okay, so next coming to the next slide, we have the third moment business decision. So what is this third moment business decision? So first moment is nothing but the first set of questions any management will come up with. And the third moment business decision is also the third set of questions any management department comes up with. So third moment business decision is called as QNES. What is it? Third moment business decision is called as QNES. And then before discussing about the third moment, first let's see, there is first moment present, there is second moment present, and now it comes the third moment. So as we have seen, first moment consists of mean, median, and mode. And second moment consists of variance, standard deviation, and range. Now coming to the third moment of business decision, we have skewness. Okay, so here, if we are going to the second moment business decision, it is difficult for us to draw some meaningful information from the second moment. It requires some knowledge. And coming to the third moment business decision, which is skewness, it is even more difficult to draw insights. We should have some knowledge about this skewness and what is it and everything. Then and only then we can draw the insights from them. Okay, now coming to the formula. So for this particular first moment, we have the formula like mean or mu. Mu is equals to expected value, which is E of X. This is exponent 1. And here we have sigma square is equals to E of, X minus mu whole square. Squared differences we have told, right? So this is nothing but second moment. Coming to the third, we have E expected value of X, which is capital X, okay, X minus mu divided by sigma whole cube. This is the formula for skewness. So when we are going for the second moment business decision, we are using this in the formula. And when we are going for the third moment business decision, we are using this in the formula. So this is the mathematical formula. What is this? Third moment business decision is the third set of question any management comes up with. And this is nothing but skewness. And skewness talks about asymmetry in the distribution. That is later we'll talk about asymmetry and all. And before going deep into the subject, we will just discuss the mathematical formula. So this is expected value of X, E of X minus mean whole square, and X minus mean by standard deviation whole cube is the formula for skewness. Okay, when we calculate the skewness, if it is equal to 0, then we can say the data distribution or data are normal. When we plot it, when we just obtain the value of skewness with the help of this mathematical formula as 0, then we can say the data are normal. So what do you mean by normal? So as I told, when when it is cutting the distribution exactly symmetrical to the mean, then that is called as normal distribution. Here, the left and right are symmetrical. These are same. So that is nothing but normal distribution. And what else? If we have deviation from 0, like, let me erase these. So if you have skewness value is equals to 0, then normal distribution, the chart will look like this. Like, this is normal distribution. Okay, when we have skewness value which is greater than 0. So greater than 0 is nothing but data is not normal. And also this is called as positive skewness, or the distribution is positively skewed. So when we have positive skewness, the chart will look like this, which means, which means when we just have a data distribution which is having positive skewness, we have the tail towards the right more, which means the positive values are more. And when we have skewness value less than 0, this is also data is not normal, and this is called as negatively skewed. This is called as negatively skewed. And coming to here, how does the chart look like? Here we have more tail on the left side because the negative values or the lower values are more. That is nothing but skewness. What is this? Skewness, if it is 0, we can talk we can say the data distribution is normal. If it is not 0, if it is greater than 0 or less than 0, the data is not normal. Depending on the value, we will say whether it is positively skewed or negatively skewed. And the chart will looks like this. Okay, let's see what is present in the slides. Okay, so first movement business decision. So it is a measure of asymmetry in the distribution. And mathematically, it is given by the formula that we have taken before. It is x minus mu by standard deviation whole cube. And negative skewness implies mass of the distribution is concentrated on the right. If you see the charts that are provided below, so here a histogram of work experience is plotted. And here, histogram of GMAT is plotted. And when we see this, like, let me just make it smaller. Okay, so here we have histogram of work experience and histogram of GMAT. So when we just look at this, if we just draw a particular curve for these particular charts, if we draw a curve for these particular charts, if you see the tail is more towards the left, as I told, towards the right. If we have tail towards the right, that is called as positive skewness. That is called as positive skewness. If you see over here, there is a small tail present towards the left. This is not as long as the right tail. See? So this is nothing but a small tail. Maybe that does not make any difference. This is called as normally distributed data. So based on the curve coming for the skewness, you can talk, based on the curve coming for the histogram, we can tell the skewness. That is why we have discussed in beforehand what is histogram and what is density plot and what is bar plot. So let me see whether I can open my RapidMiner and I can plot the charts. Just give me a second. Okay, so I'm going to create a bar plot which I have discussed before, a histogram, and here in this particular example, they have shown histogram of work experience and histogram of GMAT rate. I'll talk about the positive skewness, positive skewness and normal distribution present in that. Okay, so before going to that, I am going to use education data. Let us see what is present in education data. So this is education data over here. I'm going to use this data set to create the charts. So here you can see there are 3 columns: data, serial number, which is the serial number of students, work experience, and GMAT. This we have already seen. I will just go to my RapidMiner and I'm going to create a blank process. So everybody, if you don't want to just use the local repository present under here in this repository panel, you can create one. Go to this drop down and you can create a repository. It is up to you. So I'll show you how to create a repository, how to create a data in that, a process in that, and how to import that data into this particular repository. So I'm going to create a repository over here. So I'll name it as, what can I name it as? Sample. Sample is already present, no? I will name it as session. Anything is fine. So I just named it as session. So I'll finish this one. So I got a new repository coming over here. And later what? In this, I want to get data. So what you have to do? You have to again create subfolders. So first folder is data. Click on OK. And I want to create one more, which is again here and subfolder. And I will create a process. Okay. Now I'm going to import the data into the session folder or a repository which I have created manually. So within this, I can right click. I can right click and see what are all the options present. If you want to just create a subfolder for this, you can create it. I'm not creating anything. Now I'm going to import the data. So import the data that is present in my computer and it is present under my documents. What is that one? That is education CSV. If you see here, there is education.csv present. I'm going to connect with that CSV file. So there are 3 columns: data serial number, work experience, and GMAT. And click on next again. You can see here, this is an integer, this is an integer, this is an integer. I'm not changing the data types or I'm not changing the format. I simply click on next and finish. I want to get it under session of data and finish. So now I got my data present. This is my data. So serial number, work experience, and GMAT. This is present under the results view. If you observe, I will just open my design view. I'll go back to the design view. Now I'm going to create a bar plot. The first we have discussed is the bar plot. So I'm going to use education database or education data set. So in order to use it, what you have to do, you have to drag and drop it. And you have to establish the connection to response and execute it. Now you will get the data. This is my normal data. Now I'll go back to the design view. So now what is our requirement? We have to create a bar plot. So where we can create visualizations, in the results we can create visualizations. So see, I'll go to the results view where you have visualizations present on the left-hand side. I'll go over here. First one I'm about to create is a bar chart. So bar, I will go for column. So bar chart, which is a column. So see, if you see here, this is work experience and this is GMAT. If you keep here, serial number is also fine. So maybe I'll go for serial number, which I've taken it as an example. So if you see here before chart, so serial number on x-axis and GMAT scores on y-axis, this chart is looking just like the same. So there are a lot of records present. Why? Because when you open your Excel, you can observe there are a lot of records present. So how many records are present totally? So there are a total of 773 records along with a column header. So that is why you are getting individual bars for each and every record, which is making the bar chart looking clumsy. This is nothing but a bar plot, which is x-axis we have serial numbers of students and y-axis we have GMAT scores, which we have shown in the screenshot. So I've used education dataset for that. And then what? So we have nothing to draw information from this particular bar plot. Then I'm going for a histogram. I'll create one more, which is histogram. So see here, I'll go and create a histogram. So I'm going to create the histogram between. So see, just give it a second. Histogram. And I'm going to take work experience and apply. So see, this is my histogram for work experience. So if I just see how my chart is looking. So histogram is nothing but a univariate chart. And what else? And histogram is creating bins. If you observe, this is a bin, which is width of this one, length is this, and so on. Okay, it is creating bins. And if I just create, or if I just draw a chart for this, or a line for this, So how is it? There is a tail present on the left-hand side more. There is a tail present on the left-hand side more. So this chart is like this. So there is more on the left-hand side. So, sorry, on the right-hand side, sorry. So when we have more tail on the right-hand side, so that skewness is nothing but greater than 0, which is positively skewed. So here, the skewness of work experience is positively skewed. So how you will know whether the work experience is having positive skewness or not? How you are telling that is positive skewness? So let me erase this. And then I'll go back to my design view over here. And here I'm going to use the operator extract aggregates. So there is an operator extract aggregates. Just drag it and drop it here in the process. So this is already connected. Just execute it. Once you execute, you can see for each and every column what is the like a statistical measures like sum, mean, standard deviation, and coming to skewness. So we have plotted a histogram for work experience. So work experience, we have told it is positive skewness. Let us check the skewness value. So you can check the skewness value is positive. So that is why the skewness of work experience is positive. In this particular screenshot as well, if you see, the histogram of work experience is positive skewness. And coming to GMAT. So GMAT is having a little tail on the left-hand side, which is nothing but it is normally distributed. Let us see what is the skewness value of GMAT. I'll go back to here. And where is GMAT? GMAT over here. So GMAT is having negative. Okay, it is taking the slight difference also as negative skewness. And for the third one, this is serial number. We have 0 skewness, which is nothing but we don't have any abnormal data present in that particular column. So this is how you can calculate skewness in RapidMiner. So skewness is the third moment business decision, and skewness is nothing but it is calculated with the help of first moment and second moment, which is x minus mu by standard deviation whole cube. And if the skewness value is 0, then the data distribution is normal. If the skewness value is greater than 0, that is positive skewness. If it is negative 0, it is nothing but negatively skewed data. That is about the third moment business decision, which is skewness. Now let's talk about the next one, which is fourth moment business decision. So we are done with histogram, we are done with skewness, and let's see what else is present. Okay, if we see the third moment business decision for skewness, what is normal, what is positive, and what is negative is mentioned clearly. Okay, so see here, so negative skewness. So negative skewness is nothing but here, for this particular work experience, sorry, for particular GMAT, we have negative skew. So the data for GMAT is negative skewed. GMAT is negative skewed. Negative skewed is nothing but, which is nothing but less than 0. The skewness value is less than 0. And normally distributed is equals to 0. For this, we have data serial number. And then we have positive skewness, which we got for work experience. Okay. When we have skewness values negative skewed or normal or positively skewed, here you will have a negative direction, which means you will have tail on the left. You will have tail on the right, which we have seen in the example as well. We don't have any deviations from the normal data. Here, for the normal distribution, this it will cut the distribution symmetrical for the mean. That is normal distribution. So when we go for this negative skewness, here the mode will be greater than median is greater than mean. We will see in the form of an Excel this example. So for GMAT, the skewness is negative. So let me erase this and go back to the Excel sheet where we have education data present. So this is my data. So what is this? Okay. Okay, so here, what did we discuss? GMAT is negative skew. Negative. So it is having negative skewness. And then work experience is positive skewed. which is having positive skewness. And then what else? The serial number is having 0 skewed, which is nothing but normal distribution. So let's see. Let's see for work experience. Where is work experience? I will just copy this work experience and I'll paste it over here. So work experience is having positive skewness rate. Let us calculate or see the relationship between mean, median, and mode. For this work experience, which is negative skewness, I'll write it here as negative skewness. For negative, I will calculate the mean, median, mode. Okay, what is the mean? How can I calculate? Okay, I have written is equals to. This is negative. Okay, so mean, how to calculate? I have to use average function. So I will use average function and I will select this column and enter. So that is my mean. And coming to the median, I can use median function. So median, select the column and enter. And mode we will use mode function. So mode, column, enter. So now what can you understand in a negative skewness? So when you are having the data distribution negatively skewed, then here the mean will be greater than median, median will be greater than mode. Okay, this is negative skewness. Coming to GMAT, GMAT is work experience. Work experience is positive skewed, right? Okay, fine. For positive skewness, mean is greater than median is greater than mode. Coming to the negative, negative is present for GMAT. I'll copy this column again. I'll perform the same. I'll paste it over here. Now I'll calculate mean for this. This is negative. Okay, how to calculate this one, which is average of this particular column, enter, and equal to median of this particular column, enter, and equal to mode of this particular column. So now if you observe over here, there is a slight difference over here, but basically how it is present, everybody, this will be reverse of this positive skewness. So let us see whether the positive is matching or not. Mean is greater than median is greater than mode. So I'll go back to the PPT. Where is this one? This one. So for positive, mean is greater than median is greater than mode. And here for negatively skewed, mode will be greater than, median will be greater than mean. So this is how we can calculate these relationship between mean, median, and mode when we are having the data distribution normal and when it is having positive skewness and when it is having negative skewness. This is about the third movement business decisions. And coming to the next one, which is fourth movement business decision. What is fourth movement business decision? What is fourth movement business decision? So here, as we have discussed up to now, 3 different business movements, like for measures of central tendency, measures of dispersion, and the third one, skewness. Now the fourth one is present, which is nothing but kurtosis. So we have the fourth business movement or movement of business decision, which is kurtosis. So what is this kurtosis? Kurtosis is the fourth movement business decision and a measure of a peakedness of distribution. So what is the peak of the data distribution? That will be talked about with the help of kurtosis. So we will see. Okay, so we have first movement business decision, second movement, third movement, and fourth movement. Just like I've mentioned, this is expected value of X, and this is X minus mu whole square, which I have written before. And third movement business decision, how can I talk about this one? This is E of X minus mu by sigma whole cube. And coming to the fourth movement is E of X minus mu by sigma standard deviation whole power 4. So this is the formula of kurtosis. So when skewness is equal to 0, I am telling that is normal distribution. So what about kurtosis? What about kurtosis? So kurtosis is not, when kurtosis is equals to 0, this is not normally distributed. I'll tell you what. Okay, fourth movement business decision is present, which is kurtosis. Kurtosis talks about peakedness of the distribution. And then what did I talk about? When kurtosis is equals to 3, then it is called as normally distributed. Then the data is normally distributed. So when kurtosis is equals to 3, that is normal distribution. And how the chart is looking like? When you plot a chart, for this, your chart is normal. There is no ultimate peak or anything. So this is distributed symmetrically across the mean. This is normal distribution. When we are having the kurtosis greater than 3, then it is called as positive kurtosis. Then the kurtosis is said to be positive. And then when we plot a chart for that positive kurtosis, how can you see the peak? So here for positive kurtosis, there will be bigger peak, but the tails are thinner. Okay, so there will be a big, like a peak is thin and tails are more. This is nothing but positive kurtosis. And coming to negative, when k is less than 3, that is called as negative kurtosis. That is called as negative kurtosis. And then when we plot a data distribution for this, here, so here see, there will be, the width will be more. And why we are talking about this in the form of 333? Before we have seen skewness, which is equals to 0, greater than 0, less than 0. So in order to match with the skewness, we have subtracted 3 from the formula. That is why here the mathematical formula will be given as x minus mu by standard deviation whole power 4 minus 3. So here minus 3, we are subtracting this in order to make it equal to the skewness values. Okay, that is different topic. Okay, so and then what kurtosis, if it is 0, that is if it is 3, that is normally distributed. If it is greater than 3, positive kurtosis. If it is less than 3, that is negative kurtosis. That is negative kurtosis. Sorry. And what else? And what else are there to discuss? So here, if we are subtracting minus 3 from the formula, that is called as excess kurtosis. If we are subtracting minus 3 from the formula, that is called as excess kurtosis. So this is about kurtosis. Let's check what is the formula given here. So that is C sigma E of x minus mean by standard deviation whole power 4 minus 3. So minus 3 is nothing but excess kurtosis. Okay. So negative kurtosis implies we have negative, we have wider peak and thinner tails. And we will see this in the form of chart as well. So here if you see, this is positive. So positive, we have more tails, but the peak, we don't have it much. And when we go to the negative, we have wider peak and thinner tails. Okay, that is the difference between positive and negative kurtosis. And coming to the kurtosis, how can you find out kurtosis in RapidMiner? We have already seen extract operator present before. Let me clear this one first. So before discussing about box plot, let us see what is present in RapidMiner for kurtosis. So here, as I have used before, in my design view, I've loaded my data and I've used extract aggregate present. I got the results of skewness as well as kurtosis at the same time. So kurtosis for this serial number is negative, which is, okay, we have to calculate in the form of 3, whether it is equal to 3, greater than 3 or less than 3, we have to see. So here, this is greater than 3. Greater than 3 is positive kurtosis. This is less than 3. This is less than 3. So these are having negative kurtosis. This is nothing but kurtosis, which is the fourth movement of business decisions. So we are done with 4 movements of business decisions. Let us open our mind map and see what is present in the mind map. So coming to the mind map over here. So we are in this particular stage, which is data preparation. Within that, we are talking about exploratory data analysis. So when we talk about this exploratory data analysis, we have discussed about first movement business decision, second movement is done, and coming to the third movement. So skewness talks about asymmetry or distribution. So we have positive skewness, which is also called right skewed, and negative skewness, which is also called left skewed. If skewness is 0, then it is normal distribution. This is third movement business decision. Coming to the fourth movement, this is called kurtosis. Coming to the kurtosis, if it is equal to 3, that is mesocurtic distribution or normal distribution. Mesocurtic distribution or normal distribution when the kurtosis value is 3. So when we subtract 3 from the kurtosis, it is called excess kurtosis. And negative kurtosis, which is less than 3, is called as platykurtic distribution. It is having wider peaks and thin tails. And coming to the third one, which is positive kurtosis. Positive kurtosis is called as leptokurtic distribution. So this is having sharp peak and thick tails. This is about the exploratory data analysis, which is having 4 business movements and how to calculate 4 business movements at once just by dragging and dropping the extract aggregates operator in RapidMiner. So that is why that is mostly preferred by even the non-programmers as well, because it is just the drag and drop interface. Just we have to learn what to use and how to use. We can use, anybody can use, not only the programming skills, like this person who is having programming skills or who can do the coding, not only them, whoever the analyst or who can't write the code, even them also can go for this RapidMiner tool, which is a no-code development tool or a platform. So this is about the business movements. And coming to the graphical representation, we have seen the univariate plots. What are those? Bar plot, histogram, and also density plot. Univariate is nothing but working on single variable. We have seen bar plot, and these are all the some other charts. You can go through these, and we have seen histogram. So histogram, what is the primary purpose? Primary purpose is to understand the shape of data distribution. So as I told, histogram talks about data distribution, whether it is normal or whether we are having the tail towards the right or left. It can be understood with the help of histogram. So the primary purpose of a histogram to understand the shape of data distribution. And the secondary purpose is to identify the outliers. And density plot is also same. It is also called as probability distribution, or it is also called as kernel plot or smoothened histogram. Okay, next we will talk about another type of univariate plot, which is box plot. So let us go to the PPT. So now we will talk about box plot. So what is this box plot? Why we are going for box plot and what is the purpose of box plot? We'll talk about that one first. Okay, so in order to understand this box plot clearly, first we will just see what is box plot and how it is present in a vertical form. That is horizontally given in this particular sheet. We will talk about the vertical one and then we'll go for horizontal. So first of all, box plot. Box plot is also another type of univariate plot. Box plot is another type of univariate plot. And then this box plot is used to identify outliers. Box plot is used to identify the outliers. And what else? And this box plot is used, box plot is also called as box and whisker plot. This is also called as box and whisker plot. So box plot is another type of univariate chart or a plot. This primary purpose of a box plot is to identify the outliers, and box plot is also called as box and whisker plot. So in order to get an easy understanding of this, let us see in the vertical form how a box plot look like and what is present in a box plot. So imagine everybody, this is your box. Sorry. This is the box and these are the whiskers. Okay. If you see this one, this is the complete data. If we are dividing it into half. Okay. First of all, this is called as minimum value. The bottom one is called as minimum value. And here the box, the starting point is called Q1. Q1 is also called as first quartile. Q1 is also called as first quartile. And then you have the middlemost line present, which is dividing the data into 2 parts. That is called as Q2. Q2 is also called as median. Q2 is also called as median. And then we have the third one, which is Q3. Q3 is called as upper quartile or third quartile. Anything is fine. It is called as third quartile. And coming to the uppermost line or a whisker coming, this is maximum value. So this is how your box plot looks like, and each and every part, what is the description of each and every part. And coming to this, the difference or the data present between the first quartile and minimum value will be 25%. because out of 100, I've divided into half, and within the half I have again one more half. So 25% of data is present in between minimum value and the Q1. And how much is present within the box here? This is nothing but Q3 minus Q1, which is nothing but interquartile range. So how much data is present in this? The middle 50% of data is present within this IQR. And coming to this one, this is also 25. So total, this is 100, 25 plus 50 plus 25. This is 100% of data. If we just combine from minimum to third quartile, how much data is present? That is 75% of data. So this is about the data and how a box plot is going to look like and all. So let me clear this and let us go to what is present in the slide. See here. So let us see the explanation here properly. Okay. So here, this is a box plot. This is the minimum. This is Q1, this is median, and this is Q3, which I have already shown. And the difference between minimum and Q1 is 25% of data. And the difference between maximum and Q3 is 25%. This is middle 50%. This is 75%. And what did we talk about before? Box plot is used to identify outliers. What is the purpose of this? To identify outliers. How can we identify outliers? With the help of box plot. So here, if you see the values present over here, so whatever the values which are greater than the maximum value and whatever the values which are less than the minimum value, those are taken as suspected outliers. Those are taken as suspected outliers. Okay, and how can we calculate this maximum and minimum? So in box plot, the minimum is Q1 minus 1.5 into IQR. This is the formula. Sorry, Q1 minus 1.5 into IQR is the formula for minimum whisker or the minimum value, and maximum is Q3 plus 1.5 into IQR. So IQR interquartile range, that is Q3 minus Q1, you already know. So whatever the values which are greater than maximum, which are less than minimum, are treated as suspected outliers. And if the values are above these maximum, above this suspected maximum and below this suspected minimum, then those are treated as outliers. So for this, what is the formula? Q1 minus 3 into IQR and Q3 plus 3 into IQR. So when it is exceeding these, then those are considered as outliers. So this is how we can identify outliers in a box plot. So what is basically the purpose of a box plot? Box plot is another type of univariate plot or a chart or a visualization. So this basic purpose is to identify the outliers. And this is also called as box and whisker plot. Why? Because we have whiskers present over here. That is why this is called as box and whisker plot. And when we look at this box plot coming over here, we have minimum, we have first quartile, this is also called as lower quartile, and this is second quartile, median, and the third quartile that we have, which is upper quartile. So here, we have seen 25% of data, 50% and 75%, and whatever the values which are less than minimum, which is Q1 minus 1.5 into IQR, and greater than Q3 plus 1.5 into IQR, these are suspected outliers. And whatever the values which are above Q3 plus 3 into IQR and which are below Q1 minus 3 into IQR, those are treated as outliers. So this is nothing but the box plot, how we are treating the outliers and all. So let me give you an example for this. Okay, so here, so I will just write a simple example with by taking normal numbers. Okay, I'll just use this one. Okay, imagine I have data with values like 10. I have values like 10 and 20, 30, 40, 50, 60 and 70. These are my values. Okay, now this is the middlemost which is sorted. So Q2 is 40. Q2 is 40. Okay, and then what? Q1. Q1, imagine that is 20. And Q3 is 60. So this is first half, this is second half. I'm taking the center one. Q1 is 20 and Q3 is 60. Now, how to calculate the minimum? Minimum is equals to Q1 minus 1.5 into IQR. So IQR is nothing but Q3 minus Q1. So IQR is equals to 40. 60 minus 20 is 40. Now minimum is equals to Q1 is 20. So 20 minus 1.5 into 40. So just calculate it. Twenty minus 60 is equal. Okay, so the values which are less than 40 are treated as an outlier here. There is no value which is less than 40. Now we have to calculate maximum. That is Q3 plus 1.5 into IQR. Which means what? Q3 is 60 over here. 60 plus the values which are above 120 are treated as outliers. In this particular data, there is no outlier. If we take this as 700, so 700 is greater than maximum value. Now this is an outlier. Now this is an outlier. That is how we will calculate or identify outliers with the help of a box plot. So box plot is another type of univariate plot which is used to identify outliers, which is also called as box and whisker plot. So this is about box plot. And also coming to the box plot, let us talk about some other thing, like there are words like percentile and quantile and quartile. Percentile, quantile, and quartile. So we have already seen first quartile, second quartile, and third quartile, right? So what is quantile, first of all? So when we are having 4 quantiles, that is called as a quartile. When we are having 4 quantiles, that is called as a quartile. When we have 5 quantiles, that is called as quintile. When we have 100 quantiles, it is called as percentile. That is called as a percentile. And what is the relationship between percentile and a quartile? So, percentile and a quartile, how can I define? So, imagine this is a box plot. This is a box plot over here. Okay, so see here, this is 0th quartile and 0th percentile. And this is first quartile and 25th percentile. Why? Because 25% is present. And this is third quartile and 75th percentile. And this is fourth quartile or Q4 and 100th percentile. If you have median, Q2, that is 50th percentile. So this is the relationship between percentiles and quantiles, sorry, quartiles and quartiles and quantiles and percentiles. So if it is 4 quantiles, then it is called quartile. If it is 5 quantiles, it is called quintile. And if it is 100, it is called as a percentile. So this is all about a box plot. So box plot is also one of other univariate plot present. It is used to identify the outliers. Let us go to the mind map and see what is present there. Okay, let us go to the mind map over here. So histogram is done. Density plot is done. Let's talk about box plot. So box plot, the primary purpose of a box plot is to identify outliers, as we talked about. And secondary purpose is shape of distribution. And this one box plot is also it also talks about the quartiles and 5 number summary. You have to read this one. So quartiles is Q1, Q2, and Q3, and 5 number summary is minimum, maximum, interquartile range, and Q1 and Q3. We have seen, right? The last one is the minimum, Q1, Q2, Q3, and maximum. And in between, we have interquartile range. This is nothing but quartiles and 5 number summary. This is about box plot. Now let's go back to our PPT again and see what is present next. So box plot is done. Now let's talk about the next one. So next one is normal distribution. So what is normal distribution, everybody? So when the data distribution is cutting symmetrically across the mean, that is called normal distribution, which we have already seen before. Okay, so when your data distribution is like this one, when the data distribution is like this, that is normal distribution because this is cutting across the mean. This is normal distribution. So let us take this as an example, like let us take over here the x-axis as height of a person and y-axis is probability. Okay, we are creating a probability distribution over here. So here we have taken height of a person as x-axis and then probability on y-axis. Now what? Now what? So for suppose, imagine okay, let me take some other color. Okay, so here I am taking 1 feet people. 1, 2, 3, 4, 5. Just random, okay? Just for your understanding, I'm just writing like this. Okay, if the height of the person is like this 1, 2, 3, 4, 5, 6, and so on. So this is a histogram as we have seen. So histogram or probability distribution or density plot, anything is fine. So here it talks about the peak. So what is this peak indicating? So the maximum number of what is that? People are occupying this particular space, like the height of a person or like a majority of population are having the height in between 4, 5, and 6. This is the information that we can gain from this particular plot. So when we take some other example, like what? Some other example like what? So whenever we just plot a chart by taking profit or loss on x-axis and probability on y-axis, then what happens? So for suppose we may get how much maximum amount of profit a company may get. We don't have any limited values, right? You can have like in 1 month, there will be more profit. In 1 month, there will be less profit. So if it is less, then that is called as loss. So it may be ranging in between plus infinity to minus infinity. That is why you can here see the point. The normal random variable takes values from minus infinity to plus infinity. And also when we are when we are talking about profit or loss or height, this comes under continuous random variable. This is continuous. Yesterday we have talked about discrete probability distribution and continuous. When your random variable is continuous, such type of probability distribution is called as continuous probability distribution. So what is continuous probability distribution? When your probability is distributed across different events and the random variable is continuous, that is called as continuous probability distribution. So how can I call it? Normal distribution is one kind of continuous probability distribution. Okay, and the first point that we have seen is the normal random variable value ranges from minus infinity to plus infinity. And as we have told in yesterday's example, whenever we flip a coin, either we get heads or tails. Anything is possible. When we flip a coin, anything is possible. We may get heads or we may get tails. So there is probability of both of these possible values, which is a random variable. So how much probability is there for heads? That is half. That is expect like a number of interested events by total number of events. And tails is also half. When we just add these two probabilities together, we'll get 1. So yesterday we have seen this one. So when we are talking about a probability distribution, then we add the probability distribution of multiple events which is equal to 1. That is why the area under this curve will always equals to 1. That is the second point. So the first point is, so normal distribution is whenever the data is distributed or whenever whenever it is cutting the distribution of data symmetrically across the mean, then we can say that it is normally distributed data. And also we can use histogram and we can use box plot to talk about the data distribution, density plot, anything is fine. Now what? Now we have taken an example of height of a person and probability, and we have seen this example. And within this, what we have understood, always the random variable will be on x-axis. And yesterday we have talked about this probability distribution. Whenever our probability is distributed across multiple events, then it is called as probability distribution. Okay. And whenever the random variable of that probability distribution is continuous, it is called as continuous probability distribution. Sorry. It is called as continuous probability distribution. So what you are talking about, that is called as continuous probability distribution. And then the probability or the normal random variable value ranges from minus infinity to plus infinity. It ranges from minus infinity to plus infinity. And what else? The last point, the probability associated with any single value of a random variable will be always zero. What is this point? So here, for suppose I want to calculate the probability of, so probability whether I will have lunch. Okay, whether, okay, I want to calculate the probability whether I'll have lunch or not. So whether I will have lunch or not, it is my question. So I may have lunch or I may not. So these are the two things that may be present. I may have lunch or I may not. So this is half of the probability. This is half probability. When we add these together, we'll get 1. Okay, this is fine. So when we have continuous probability distribution, like I want, like whether I will have lunch exactly at 1 p.m. or not, that is what I want to calculate the probability for. So 1 p.m. maybe, this is continuous. You can take it as 1, exact 1, or I can take it as 1 with 1 second and microseconds. So you have a lot of units present over here. When you have such type of continuous data, then it is called as continuous probability distribution. So when you have continuous probability distribution, what happens? There we have infinite number of probabilities to occur. So how can I calculate the probability? How many total number of events are present? Infinity. So 1 by infinity is equals to 0. So the probability associated with any single value of a random variable is always 0. That is what the 3 points mentioned over here. So the normal random variable takes the values from minus infinity to plus infinity, and the area under the entire curve is always equals to 1. And the probability associated with any single value of a random variable is always 0. This is normal distribution. And coming to the next one, what is present next? Coming to the next one, we have QQ plot. So what is this QQ plot? So QQ plot is also another type of univariate plot. We'll check it in the mind map after discussing about this. So QQ plot is called as quantile plot. QQ plot is called as quantile plot. And this is also one of the univariate plot present. And here it talks about whether the data distribution is normal or not. So how to check whether the data distribution is normal or not with the help of QQ plot? So this QQ plot, it will plot the quantiles of the sample data against the quantiles of theoretical data. If you see on x-axis, there is theoretical quantiles present. How you are getting this theoretical quantiles? By using standardized scaling. So what is standardized scaling? We'll talk about the standardized scaling in a bit. So before that, we'll talk about the QQ plot. So QQ plot is one type of univariate plot. This QQ plot is called as quantile plot. This is also useful to talk about the data distribution. Whether the data distribution is normal or not, we have to check with the help of a QQ plot. So now we have histogram, we have box plot, and we have QQ plot to talk about the data distribution. And what else? So here, the quantiles of the sample data is plotted against the theoretical quantiles, which we get using standardization or standardized scaling. This is QQ plot. Then how can you tell whether the data distribution is normal or not? So how can you say the data distribution is normal or not? So you can talk about the data distribution, whether the data points are on the straight line or not. So what is straight line? So if you go over here you can check these mostly are present on the straight line itself. Here you can see a red line coming over here. So most of the data points are present on the straight line. So now you can say the data distribution is normal. If the data points are deviating from the straight line coming over here, then you can say the data distribution is not normal. This is how we can talk about the data distribution using QQ plot, another type of univariate plot. Let's go to our mind map and check it what is there. So box plot is done and Q plot. This is also called as quantile plot, normal Q plot. This is about Q plot. So these are the various charts or plots that you can create for univariate purpose. Like when you are working with a single variable, you can go for these charts. Now what? Whereas bivariate is also present. We will check it out later. We'll go to our PPT. So Q plot is done. Let's see what is present next. So here, the next sheet is talking about the characterization of normal distribution. So what it is talking about? The characterization of normal distribution. If you check over here, when we have a bell-shaped curve coming, that is nothing but normal distribution. So normal distribution is characterized by a bell-shaped curve. What is it? Normal distribution is characterized by a bell-shaped curve, and some of the empirical properties present over there are 68.26% of values lie within plus or minus 1 standard deviation from the mean. So what is this one? So as you can see, this particular chart, bell-shaped curve, this is nothing but normal distribution. So the left and right will be symmetrical, and here the mean is equal to median is equal to mode. Okay, this is fine. And coming to the next one, if you see over here, this is mean, this is minus 1 standard deviation plus 1, plus 2 minus 2, plus 3 minus t, and so on. Okay. Okay, now what? So for suppose you have a ball, any product, not only a ball, any product you can take. So what is this percentage talking about? So now you have a ball. If the okay, fine. You have a ball, and imagine the circumference of this is in between 224 to 220 or 230. Anything is fine. It is in between 224 to 230 mm. Now, when you are manufacturing a lot of cricket balls or balls, what can we talk about based on standard deviation, the normal distribution? So when we are taking the normal distribution based on standard deviation as plus or minus 1 standard deviation, then it will be deviating from 0 to minus 1 to plus 1. That is x, which is mu, the mean, plus 1 standard deviation, and x bar minus 1 standard deviation. So that is nothing but the area or the range which is satisfying the customer requirements. When we are having plus or minus 1 standard deviation, so it is nothing but 68.26 values are satisfying the customer requirements, which is in between 224 to 229. So what else the others? So if you take this as 68%, if I take this as 68%, then what else are remaining? 32 are remaining. But this is normal distribution rate. So normal distribution means right and left should be same. So 32 divided by 2, it is 16. So 16 values will be here and 16 values will be here. And remaining 68 will be here. So out of 100%, when we are taking plus or minus 1 standard deviation, 68% are satisfying the customer requirements, and remaining 32% are divided into 2 equal parts because this is normally distributed data, which means the left and right having the same values. So 16 are present on left and 16 are present on right. So when we are taking plus or minus 2 standard deviation, it is 95.46. If we are taking plus or minus 3 standard deviation, this is 99.73. And here you can take plus or minus 4, plus or minus 5, and plus or minus 6 as well. So this is the normal distribution empirical properties based on standard deviation. So you have to remember these values, like when it is 1 standard deviation, how much is the percentage? When it is 2 standard deviation, how much is the percentage? You have to know all these things. And coming to the next sheet. Coming to the next sheet, we have z-score and standard normal deviation. So what is z-score and what is standard normal deviation? So here, for suppose imagine, so now you have normal distributed data. So for normally distributed data, you will have some mean rate. And when we just Standardized. We have seen in QQ plot, we are standardizing the scaling and just plotting the chart against the theoretical contents rate. So what do you mean by standardizing? What do you mean by standardizing? So we are standardizing the normal distributed data. So now what you will get some other chart and you will get some other thing. So now when you standardize a normally distributed data, the mean that you have in this data will be converted into 0. For standardized scaling, or when we standardize the normally distributed data, whenever you are converting, the mean will be converted into 0. And also we have seen the random variable range is from plus infinity or minus infinity to plus infinity. This is random variable which is present in normal distribution. But when we standardize the data, here it ranges between minus 3.4 to plus 3.4. Minus 3.4 to plus 3.4. This is about standardization. So what is standardization, everybody? So let us see what is present in the slide. So normally distributed data is present. The mean value is 1010. Now, we will standardize this normally distributed data. When we standardize this, we got a standard normal distribution. So within this, the mean is converted into 0 and it ranges between minus 3.4 to plus 3.4. And also for every value of random variable, we can calculate the z-score. So z-score calculation is x minus mean by standard deviation. So z is equals to x minus mean by standard deviation. That is how we will do the standardization using z-score. So standardization is nothing but we are converting the normally distributed data into standard normal distribution. So for this, we are using z-score. Z-score is nothing but x minus mean by standard deviation. Then what else? So we have one more chart present, which is scatter plot. What is the scatter plot? So scatter plot, before that, we will see what is scatter plot. Okay. So scatter plot is also, scatter plot comes under bivariate plot. We have seen in the mind map before. This is a bivariate plot. Bi means two variables. We are creating this scatter plot by using two variables. And then what? The primary purpose of a scatter plot, is to talk about direction of two variables or direction of correlation, strength of correlation, and then whether this is linear or non-linear. This is the primary purpose of a scatter plot. And there is a secondary purpose as well. The secondary purpose is to identify outliers or clusters. This is the secondary purpose of a scatter plot. Now, how it talks about the direction, strength, and linearity. Okay, first suppose imagine you have plotted a chart or plotted a graph. Here, I have taken on x-axis. Okay. I will take on x-axis the time spent. So how much time you are spending for shopping. And on y-axis, I will just write how much amount I am spending. So when I spend more time in the shopping mall, I'll just spend more amount, right? So when x value is increasing, automatically the y value also increasing. So when you have such type of relationship between two numerical variables, then that direction is called as positive direction. Why? Because when one is increasing, other will be increasing. That is like this. That is nothing but positive direction. And then what? Strength. Related to strength, when the data points are closely packed together, then that is called as strong strength. So when the data points are closely packed, we will say the strength between the two variables is strong. If they are cluttered somewhat, that is moderate. If they are very distant from each other, then that is weak. And linearity, non-linearity, you can say by looking at the scatter plot itself. When the data points are on the straight line, those are linear. If it is not in the form of straight line, that is non-linear. So we will see in the charts of with the help of an example. So first of all, scatter plot is another type of chart, which is a bivariate plot. So bivariate, bi means two, So we are using the scatter plot in order to talk about the relationship between two variables. The primary purpose of a scatter plot is to find out the direction of correlation and also the strength of correlation and whether the relationship is linear or non-linear. And the secondary purpose is to find out the outliers or clusters. And also we have directions as positive, negative, and strength as strong, moderate, and weak, and linear or non-linear. So when we have this concept, like when one value is increasing, another value is increasing, then we have direction of relationship to be called as positive. And then what? How can you talk about the strength? When the data points that is present in the scatter plot are closely packed together, then that is strong. If they are cluttered somewhat, then it is moderate. If it is not closer together, they are very distant from each other, that is weak. So this is how we talk about with the help of a scatter plot. So let's see what is present in the slide. Okay, so strong positive correlation. So see here, one value is increasing, another value is increasing. This is positive direction and the data points are closer together. So this is strong. And this is also in the form of a straight line. This is called as linear. So what is this? This is positive direction and strong, strength is strong and it is linear. And coming to the next one. This is moderate positive correlation. So here one value is increasing. Sorry, here one value is increasing, the other value is also increasing. So that is positive. And what else? The data points are not very closely packed together, just like in the first case. Here the data points are somewhat cluttered. That's why this strength is moderate. But these are in the form of a straight line itself. So this is linear. And coming to the third one, we have moderate negative correlation. So here if you see, if one value is high, the other value is low. If one value is high, the other value is low. So this is opposite of the positive direction. So when the direction is like this, which is which is reverse of the positive direction, then you can call the direction of the correlation is negative. And what is the strength? Strength is the same. If they are tightly packed together, it is strong. If they are cluttered somewhat, it is moderate. If they are distant from each other, that is weak. And the last one, strong negative correlation. The direction is negative, but the data points are closer together. That is strong negative correlation. And the next one we have is no correlation. Here, because we don't have any direction or any relationship present. So this we can call here as this relationship is weak or this correlation is weak. And this is not linear. This is weak and non-linear. And coming to the next one, which is curvilinear relationship. So what is this curvilinear relationship means? If you observe over here, okay, curvilinear relationships, if you observe over here in this, if you observe over here in this particular chart, like when I plot a chart like this, just a second. When I plot a chart like this, and I got a single curve like this, just like this. So now, which means I have one bend present. So if it is one bend, this is called as polynomial with 2 degrees. This is called as polynomial with 2 degrees. And here in this curvilinear relationship, you can see there is no linearity present, that is non-linear. So these are about the scatter plot, how it is looking and all. This is the primary purpose, to talk about the direction, to talk about the strength, to talk about the linearity. So what about the secondary one? What is the secondary purpose? Secondary purpose is to talk about whether the outliers are present in the data or not. If you see here in this particular scatter plot, if I have, so for suppose I have data points like this. Okay, this is not closely packed, but this is positive and moderate. This is fine. But when I have an extreme value present when I'm creating a scatter plot, so I can treat this as an outlier. So the secondary purpose of a scatter plot is to detect the outliers and also can check, for suppose in this, some are closely packed here, some data points. And here there are some other values. And here there is one more cluster. So when you just look at this scatter plot, you can identify the clusters as well. So the primary purpose is to talk about direction, to talk about strength, and to talk about linearity of relationship or correlation between two variables. And secondary purpose is to identify the outliers or identify the clusters. So this is about the bivariate plot present, which is scatter plot. Now let's check the mind map, what is present there. Okay, we have discussed the univariate plots, which is bar plot, histogram, box plot, density plot. We have seen QQ plot, all of these univariate plots. And coming to the secondary plot, bivariate plots, you have scatter plot present. So data preparation and explanatory data analysis, graphical representation, bivariate. So in this bivariate, we have scatter plot present. So what is purpose of scatter plot? Let's see in this mind map. So scatter plot primary purpose is to talk about direction. This direction may be positive, negative, or no correlation. And strength may be strong, moderate, and weak. And it also talks about linear and non-linear. Secondary purpose is it is used to identify the outliers or identify the presence of clusters. And what else is present in this particular slide over here? There is one more point here. So see, the strength, strong, moderate, weak, this is subjective. Why? Because if you observe this one, if you observe this chart, so some may think like these data points are closer together. That is subjective. It depends upon the person. So that is why in order to make that objective, we have had a concept called as correlation coefficient. Correlation coefficient is always represented with the help of R. If the R value is greater than 0.85, then we will say the strength is strong. If it is less than 0.4, then it is weak. If it is in between, that is moderate. So always the R value ranges between -1 and +1. With the help of this correlation coefficient, we can talk about the strength of relationship between two variables. Okay, this is about the scatter plot. And there is one more point in this disadvantage, what is present in the mind map of scatter plot. So the disadvantage is the strength is subjective. That's why we have correlation coefficient. If R value is greater than 0.85, that is strong. And if it is less than, that is moderate or weak. And weak and in between is moderate. And it ranges between -1 to +1. Okay. And there is one more concept called covariance versus correlation. So when we are talking about correlation, it talks about direction as well as strength. So here, correlation talks about direction as well as strength, whereas covariance don't talk about both of the things. It is determining only the direction. That is the small difference between correlation and covariance. So this is about the bivariate plot present, which is scatter plot. Okay, coming to the next one. What is present next? So scatter plot. And this module is done. So what did we discuss in this current module, everybody? So we have seen the left out business movements, which we haven't discussed in yesterday's session. So first of all, we have created a bar plot. So bar plot, when we observe the first bar plot, I can't get much of the information from this bar plot. That's why I have gone for the second type of univariate plot present, which is histogram. So histogram is called as frequency distribution. It is creating bins when we are creating a histogram. And the difference between histogram and a density plot is histogram on x-axis, you will have random variable. Sorry, on y-axis, you have frequency. Whereas here, you have, here in the density plot on x-axis, you have random variable. On y-axis, you have density or probability. That is the small difference, and both are univariate charts. And the next one we have is third moment business decisions. Third moment business decisions is nothing but skewness. It talks about the asymmetry in the distribution. The formula for that is E of x minus mu by standard deviation whole cube. So when the skewness is 0, that is normal distribution. When the skewness is greater than 0, that is positive skewness. When the skewness is less than 0, that is negative skewness. We have seen everything with the help of an example as well. And we have also seen the skewness values of education data set in DataMiner tool as well. And the second one that we have here is fourth movement business decision, which is kurtosis. So this is a measure of peakiness of distribution. So the formula is like this in order to match with the skewness that we talked about. So if kurtosis is equal to 3, then it is called normal distribution. If it is greater than 3, it is called positive kurtosis. If it is less than 3, that is called negative kurtosis or platykurtic distribution. Anything is fine. And if we are subtracting -3, then it is called excess kurtosis. And then we have seen another type of chart, which is box plot. It is used to identify the outliers, and it is having quartiles and 5-number summary. This is nothing but box plot. And the normal distribution, here there are 3 important points. The random variable ranges between -infinity to +infinity, and the area under the curve will always be equals to 1. And the probability associated with any single random variable is always 0. And QQ plot is also another type of univariate plot. Here they will use here they will standardize the scaling and then plot the quantiles of sample data against the quantiles of theoretical data. So that is when you will get the data points. If the data points are present towards the straight line, then it is called the data is normally distributed. If not, the data distribution is not normal. And then normal distribution is characterized by some of the empirical properties based on standard deviation. And sorry, we missed this one, I guess. So this normal distribution for a random variable, if we have mean and standard deviation, we can just characterize the normal distribution of that random variable. So if you see here, if mu is equals to 0 and standard deviation is equals to 1, the plot will be different. So see here first, let me show you clearly. So normal distribution, so characterized by first mu is equals to 0 and standard deviation is equals to 1. So when the standard deviation is equals to 1, okay. So see, you can see the changes. So when mean is constant and standard deviation is changing, the width will change. So see, first of all, the width will change for standard deviation 0.5. So see, the peak is increasing and width is decreasing. When we change the standard deviation to 2, there is wide width present. And if it is having mu equal to -1, it is shifting the position. So depending upon the mean and standard deviation of a random variable, we can characterize the normal distribution. This is the next one. And we have seen how to standardize when we have normally distributed data. If we standardize that, the mean will become 0. And also the range from -infinity to +infinity will become -3.4 to +3.4. And then Z is equals to x minus mu by standard deviation is the formula. And the last one we have is scatter plot. It is a bivariate plot. It is used to find out the direction and strength and linearity of the correlation between two variables. And also scatter plot is used to identify the outliers and also identify the clusters. But this concept of direction or the strength is subjective. Sorry, the strength is subjective. That is why we have the concept called correlation coefficient. So based on the value of correlation coefficient, we can tell the strength of relationship between two variables. So this is about scatter plot. So we can create scatter plot and we can just do the standardization, everything in RapidMiner. Let's go back to the RapidMiner. So if you check this operators over here. So let's see the operators, what are all present. So here, if you want to go for cleansing the data, you can go for cleansing. And we are talking about the normalization rate. So here, under the normalization, you can go for normalize also. I'll delete this. Okay. So here you have normalize. If you want to normalize the data, you can normalize. Use this one. Like what? I'll just delete this one. And I will just create normalize over here. Okay. So you can select what is the attribute that you want to normalize. So I want to take a single attribute, maybe GMAT. So see, it is normalizing this GMAT scores, which is present before 600, 700 and all. Now this is different. This is nothing but normalization. What did I do? I changed the parameters over here. You can do whatever you want. Okay. And denormalization, you have one more operator. Scaling, you have one more operator. And for blending, you have different operators like attributes and examples. For tables, for sorting, for values, everything you have individual operators present. You can just drag and drop in order to perform that particular operation. That is why this is called as drag and drop interface with no code development platform. If you want to get the statistics, you can go for statistics. So see, we can, when you hover the mouse button, you can see the purpose as well. The group predictive. This is group. When you open predictive, you can see all those different things present. We won't use most of those. If you want to work on this, you can just see what is the different types of methods present, and you can just work on everything over here. So to forecast, to validate, all of these are present. For normalization, these are present. Everything is present over here. Okay, and what else? We will go to the next part, which is data pre-processing part. We are done with exploratory data analysis. Now we will talk about data pre-processing. So coming to the data pre-processing, let me close this one. So coming to the data pre-processing, we have data preparation. So data preparation is also called as data pre-processing, data wrangling, data cleansing, data organizing, etc. And then in this particular module, we are going to discuss data cleansing and organizing, typecasting and handling duplicates, outlier analysis, zero variance features, discretization and encoding, missing values, feature selection, data scaling, and transformation. Everything we'll look after in this particular module. Okay, let us go to the first slide. Here we have data cleansing and organizing. So if you see here this data, let me show you properly. So here, if you see this data, here we are recording whatever the operations that are happening over there. So when you see this one, there is an unknown, like unnecessary data coming over here. This one, which is presented in red color box. This is not the data that actually happened. So we will go for data cleansing. So data cleansing is nothing but unnecessary data. We will just remove it. And coming to the organizing. So here, if you observe, the first box is unstructured. There is no proper structure present for this. So whenever we do the organizing of data, it is converted into table format, which is structured data, and it created two individual columns, and accordingly the data is arranged. So this is the basic, which is data cleansing and organizing the data. And let's see the next one. Next one, we have typecasting and handling the duplicates. So what is typecasting and what is handling the duplicates? So typecasting is nothing but converting one data type into another data type. What is it? Converting one data type into another data type is nothing but typecasting. Let us see what is present. So typecasting is also called as type conversion, type coercion, and type juggling. Okay. So here there is an example present here. So we have to convert or this typecast the people or the children who are working instead of going to school. That is a small example present here. So we will see typecasting in RapidMiner. So let me open my RapidMiner over here. I will just delete this one, which I've already done. Now I'm going to use a data set. What data set I'm going to use? Let me see. Just a second. So here, see, I have a sample data present over here, which contains 4 columns: name, age, gender, and weight. So this is normal data. So what is this typecasting? If you want to convert any one into any type, you can just convert typecasting. For suppose, okay, fine. What I do is, I will go back to my RapidMiner and I will load this data. So I don't want it permanently. So I will go for read Excel. That is an Excel file. So read Excel. And I'll double click on it and I'll give the location of the file. So this is a present here. That is why this is not loading. Let me close this one. Okay. Now I'll go to previous. So I loaded the sheet over here and there are 4 columns present. And if you want to format it, you can format it. I'm not formatting it. This is polynomial. This is integer. This is polynomial. This is integer. Okay. Now, if you want to convert any type into any type, for suppose name we have ABCD, which is polynomial, right? Now, if I want to convert it into any other type, we have a concept called typecasting. So what I do is nominal to numerical. So before doing that, I'll execute this one. Okay, I did not select the data. First of all, what I do is, just give it a second. So here, see, name, everything is converted into individuals and gender. Because I've selected all, right? I'll go back and what I do is, so for this, instead of selecting all, I'll select the single value, which is belonging to name. So name, we have A, B, C, D and all, right? So name I'm selecting, I want to convert it into numerical. That is polynomial before, I want to convert it into numerical. So see, this is how it does in RapidMiner. So converting one data type into another data type, not only numerical into nominal, you can convert into number into date, whatever that you want. That is nothing but typecasting. Now we will see what is present next. We have the next one, which is handling the duplicates. So how to handle the duplicates? So when you have multiple records with the same information, so that is not needed, right? When you analyze the data once, that is not needed to analyze again the same data again. So that is when we will go for handling the duplicates. We mostly go for removing them. So I have a data present with me, which is duplicate data. So what I do is, I'll just remove this one. So everybody understood the typecasting, I hope so. So I'll just delete this as well. And I will load again one more data, which is to show you handling the duplicates. Because in sample superstore or whatever that we are using, we don't have any duplicate values. So here I will just connect with a small data set which is having duplicate records. So I've named it as duplicate records. I'll load it and show it to you. So here if you see B, everything is repeating, and F, everything is repeating. So there are few records which are repeating. So total we have 12 along with the column header. So I'm not changing anything. Next, finish. So I got it. Now, in order to remove the duplicates, what you have to do, you have remove duplicates operator present. Just use this operator over here and give the connection. And for this, if you want to select based on one column, you can select it. But based on all columns, I want to remove the duplicates. And I will execute this. So see, before you have 12 records, but now I have only 9 records. Along with the column header, we have 10. So 2 duplicate records got deleted. This is how you can handle the duplicates in RapidMiner. So what did I do? I just loaded one data and I have used one operator and executed it. That's it. I did not do, or I did not write any code just like in Python. So this is very much easy for anybody to do in RapidMiner. This is how you can handle the duplicates. We have seen typecasting and how to handle the duplicates with the help of a single column or multiple columns, anything according to your requirement. Now, next, what is present? Next, we have outlier analysis. Next one that we have is outlier analysis. So what is this outlier analysis? So let me talk about this outlier analysis in a detailed manner. So we have the next concept, which is outlier analysis. So when we are having extreme values present in our data, as we have talked about before, when the value is extremely high when compared with other values, or it is extremely low when compared with other values, that value is treated as an outlier. That value is treated as an outlier. So when you have outliers in your data, you will go for this technique called as 3R technique. So 3R technique is, one is rectify, second one is retain, and third one is remove. So what is rectify, what is retain, and what is remove? So for suppose you have data present over here each and every month, and what is the sales? So if you see the sales of May is higher when compared with others. This is extreme value. If you have extremely low value, it is also treated as outlier. So in your current data, you have outliers. Now you can check whether you have to go for rectify, retain, or remove. Okay. So for suppose if you ask your salesperson why the sales of May is very high when compared with other months. So if he answered like, oh, sorry, because of I just copied and pasted the data, I by mistakenly entered the number wrong. So when you have such accidental errors, you can go for rectify. And what is retain? When you have to go for retain. So the salesperson told like we have just like used some of the innovative techniques on during that May month. That is why we got a lot of sales. So when we have like a requirement like this expected value that you got, if you have like if the chances of getting that extreme value future in the future data as well, when you have such type of situation, you can go for retain. When you have the situation like there may be chances of such extreme data to be appeared in your future data as well, then you have to go for retain. Then what is remove? Remove is opposite. When there is no possibility that that particular extreme value that you have got is appearing in the future data. It is not there is no particular chance for that. Then you have to go for remove. So these three you have to check what you have to go for, whether you have to rectify the outliers or retain the outliers or remove the outliers. Okay, this is about the 3R technique. And coming to the next one, we have Winsorization. So Winsorization, here we will use the percentile. What is it? Here we will go for here we will go for a percentile. I will take any one, any percentile is fine. So I will take 50th percentile. Okay, sorry, I will take 5th percentile. So when I take 5th percentile, whatever the values which are less than minimum are replaced with 5th percentile. Whatever the values which are less than minimum are replaced with 5th percentile, and whatever the values which are greater than maximum are replaced with 95th percentile. This is what happens when we go for Winsorization technique. So when you have outliers present in your data, you have to check whether you have to rectify them, retain them, or remove them. And within that, we have Winsorization. In Winsorization, we have to take a percentile. So based on that percentile, the outliers are getting replaced with 5th percentile or 95th percentile. Next we will see what is present. Let me delete this. So next we have is trimming. So what is trimming? Trimming also just like Winsorization, here we will take an alpha value. When alpha is equals to 5%, then what we do, whatever the values which are below the 5% are removed. Here we are not replacing the values. Trimming is removing the values. And whichever are 95th percentile above 95%, then we will just remove them as well. So in Winsorization, we are replacing the values, and in trimming, we are removing the values. So these are the different things present. And what else? So we have masking. So masking is outliers are present, but we are failing to detect those outliers. So this may happen for a lot of reasons, like because of we did not analyze the data properly, or we may have used a wrong technology. Because of all these reasons, we may get this false negative, which is we may fail to detect the outliers, even though they are present. And what is swamping? So what is swamping? So swamping is detecting the non-outliers as outliers. This is also called as false positive. So what is this one? False positive. So when you have outliers present in your data, still you can't detect them as outliers, that is masking. If you are detecting the non-outliers as outliers, then it is called swamping. So why does swamping happens? So because of we don't have proper knowledge, we are just considering the non-outliers as outliers as well, or because of some oversight, there may be a lot of reasons. So these are the different topics present under outlier analysis. So if you have outliers present in your data, you can go for rectifying them, retaining them, or removing them. And you can use the percentile with the help of winsorization and replace those values. And we can use the alpha percentage and you can trim those values using trimming. And then what else? What else are there? So we can use the standard deviation approach as well. So when the data point, standard deviation, we already talked about this, plus or minus one standard deviation, 2 standard deviation, 3 standard deviation. So when we are using standard deviation approach, what are all the data points which are below, for suppose I'm taking X bar plus or minus 3 standard deviation. If this is my case, whatever the data points that are below minus 3 standard deviation, which are above plus 3 standard deviation, those are outliers. Okay, so when we are using standard deviation approach, this is the case. And what is the next thing? What is the next thing? Next one we have is IQR technique, which we have seen. So IQR is Q1 minus 1.5 into IQR is minimum. Q3 plus 1.5 into IQR is maximum. Whatever the values that are less than minimum are outliers, and whatever the values which are greater than maximum are also outliers. That is called as interquartile range, IQR technique. And also we have automatic outlier detection, which we will use in prediction models. We won't discuss about this here. So this is about outlier analysis. So what is this one, everybody? So up to now, under the data pre-processing or data preparation or data munging, whatever it is, we have seen a few things like data cleansing, organizing the data, and also typecasting and handling the duplicates we have seen in RapidMiner as well. And also the next one we have is outlier analysis. When you have outliers present in your data, you can go for rectifying them, retaining them, and removing them. And what else? You can go for the percentiles and go for winsorization and replace those outliers with some percentile that you have taken, and trimming. But you can go for the alpha value and you can trim the data according to those alpha values. And also you have masking and swamping. And also you can go for identifying the outliers using standard deviation approach. Standard deviation approach are based on whatever the standard deviation that you take, the values which are below that particular minus standard deviation and above the plus standard deviation are treated as outliers. And using the box plot, you have IQR technique. These are the various techniques or methods present for outlier analysis. So this is about outlier analysis. Next what? Next one that you have is zero and near zero variance. Zero and near zero variance features. So what is this? Features is nothing but columns or variables. Anything is fine. So what is zero and what is near zero? We will talk about that. So for suppose, if you are having a data set, if you have a data set with few columns like name, age, gender. Okay, let me take the data set. Okay, so let us take a sample data set. Okay, so for suppose you are having a data set which is having the columns name, age, gender, and income. So these are the few columns present. So there is a name. Okay, I am not writing names here, just ABCD are enough. Okay, now age, I will write random 20, 21, 22, 22. And gender, this is male, this is male. And income. So these are the various values present in your data set. Okay, so now this is the output variable and these are the input variables, x1, x2, x3. Now, if you are analyzing this data, then you can observe all the values present in this particular gender column are the same. There is no different categories present here. So without this column also, I can analyze the data because that is not of much use because all the values are same. So you can go for removing that particular column having the same value. That is nothing but zero variance features. What is near zero then? So if you have a like a proportion like, for suppose male is present, female is present, male is present, male is present, male is present, female is present. So if a gender column is having these values, now when you compare the proportion of male to female, so male proportion is occupying mostly 98%, female is just only 2%. So when you have different categories present in a particular column, and if those categories, one category is one category is dominating the other one, more like not only 50-50, that is not 50-50. This is mostly present, which is 98%. When you have such type of situation, you can also go for removing that column, which is called as near zero variance. This is zero variance, which is having the single value in the data or a column. If you are having one category occupying most of the proportion, then it is called as near zero. Near zero. Now, this is categorical data. What we are working is categorical data. Now, when you have numerical data, so for categorical data, you can go for the proportion just like this. But when you have numerical data, what you will understand from numerical data, how can you remove this zero and non-zero columns? When you want to do this zero and near zero variance in numerical column, you have to go for variance. So you can take the variance like, whatever if the variance of that particular column is less than 5%, then I have to remove that column based on the value that you take. So when you have categorical column, you can go through proportion, and when you have numerical column, you can go through variance. This is nothing but zero and non-zero variance features. We will check it out what is there in the slide. So here see, so identify the column that contains a single value. Here, if you see every column, this particular education column is having all the record values as graduate. So there is no much use. There is no much use from this column to analyze the data and all. And the second one is identify the columns with few unique values. So female is less than 1%. So that is a near zero variance feature. And what else? So when you have numerical columns, you can go for variance, which I have taken it as less than 1. This is nothing but zero and near zero variance features. This is one more data pre-processing step. And coming to the next one. What is next one? Next one is discretization and encoding. What is discretization and what is encoding? So discretization is, what can we say? There are some machine learning algorithms which expect your data to be in categorical only. What is it? Some machine learning algorithms expect the data to be categorical only, just like in decision trees. So decision trees want to have the data to be in categorical only. So that is when we will go for the concept called as discretization. So discretization converts numerical data into categorical data. What is it? So we have the next data pre-processing step, which is discretization and encoding. So discretization is when you will go for discretization when you have numerical data present, but when you are applying some algorithms over there, machine learning algorithms, that machine learning algorithms expect your data to be in categorical only, not numerical. So in such type of situations like decision trees and all, you will go for discretization, where you will convert numericals into categorical. Numericals into categorical. So when you are doing this, you will have some rules. We will see in the form of an example over here. So in that we have different types, binarization, and we have rounding, all those things. Before that, we will take. Okay. So here, discretization is converting numbers into categorical. This is discretization. And then here we have an example. So we are converting the salary, which is a numerical column, into categorical column, which is category. How did we do this conversion? How did we discrete the data? How did we perform discretization on the data? So here we will go for few rules. So if the salary present in that record is less than or equal to 4,000, you always go for less than or equal to, there is a mistake over there. Okay, less than or equal to 4,000, you indicate that as low. If it is greater than 10,000, that is high. And in between we have is moderate or medium. So based on these three rules, I have converted my numerical column salary into categorical column. That is called as discretization. So 6,000 is not less than 4,000. So this is medium. 8,000 is also not less than 4,000 and greater than 10,000. So this is medium. So 12,000 is greater than this one. So high. 2,000 is less than 4,000. So low. So depending upon the rules that you have given, my numerical column is converted into categorical column. This is called as discretization. So what is binarization? So when we just apply only two rules, when we have only two categories. So if you observe here, there is median, there is low, and there is high. If you have only two categories, when you convert a numerical columns into two categorical columns, then it is called as binarization. We will check it out. I'll just delete this. So see, this is again one more example. This is having only two categories, high and low. So binarization, we have applied only two rules. So when we have numerical column, when we have the requirement like some machine learning algorithms are not supporting numerical, they're expecting that to be in categorical. So that's when we will convert numerical into categorical. That process is called as discretization. Okay, when we are applying the rules, if we just divide that column, numerical column into two categories, that is called as binarization. Next, what is rounding? So rounding you already know. Let me give you a small example. Okay, rounding. For suppose when you have a numerical column number like this one. So 1.25, 1.67, 1.23, 2.5. These are all the values present. Now, if you just use the rounding technique on these, you may get the floor values or ceiling values according to your requirement. So what is floor? What is ceiling? Ceiling is number up and this is number down. Like when you go for floor, this is 1, this is 1, this is 1, this is 2. Number down. And this when you go for ceiling, this is 1, this is 1.6, so this is 2. This is 1, this is 2.5, this is 3. This is the difference between floor and ceiling. So when you have one number more in the decimal place, when you are going for ceiling, it will become 2. But in floor, it will become 1 only. Number up and number down. So that is nothing but rounding. And what is the next one? Binarization is done and rounding is done. And what is binning? Binning is also called as grouping. I have already talked about this when we are talking about histogram. So binning is nothing but discretization. So when we just converted this numerical into categorical using these three rules below, we have got three groups present. One is medium, another one is high, another one is low. So this also, discretization also comes under binning. These are the three groups or bins that I have created when I converted this numerical into categorical using this method. So this is about binning. So what is this? Discretization and encoding. This is converting numerical columns into categorical columns. And within this, we have binarization, rounding, binning. Binarization is nothing but when we are converting the numerical into categorical column, we are using only two categories to get divided that into, that is binarization. And rounding is either we get floor values or ceiling values. And binning means we are dividing that into groups just like discretization. Okay. Now we will show this discretization in RapidMiner. So let us see this in RapidMiner. So within this binning, fixed width binning and adaptive binning, which is bins are having equal size. So 20, 20, 20, that is fixed. If it is not, this is adaptive. And let us go to my RapidMiner right now. And I'm going to use sample superstore and I'm going to show you the process of discretization. So let me delete this as well. So my sample superstore is already present in my local repository data, which we have seen yesterday. So I'm going to use the sample superstore. So sample superstore, I'm just going to execute this one. I got the data. So there are 997 records. Okay, now I'll go back over here. Now, so you have to go for discretization rate. That is nothing but binning. So I can go by frequency, I can go by binning, I can go by size. Anything is fine. I'll go by frequency. I'll go by frequency. If you want to discrete only one column, you can select one column. So I will go by single, and I want to just discrete the sales column. Sales column is nothing but a numerical column, right? I want to convert that numerical into, what is that? Categorical. And how many bins I want? Either 2 or 3, depending upon that, you will get it. So I will just take this as 2 bins and I'll execute it. So here, if you see, sales before is a numerical column. Now it got converted into range. So range, infinity, infinity, minus infinity. That is what you can just do discretization, how you can do in RapidMiner. So you have specific operators for discretization. So you want to discretize by binning, or whether by frequency, or whatever you want, you can do it accordingly. I've shown you one method. You can experiment on other methods as well. So this is about discretization. Now I'll get back to that PPT over there and we will see the next one. So what is the next one present? So the next one is encoding. So what is encoding here? Okay. Discretization is done. Now we'll talk about encoding. So encoding is nothing but the reverse of discretization. So certain machine learning algorithms can't take categorical data. Some machine learning algorithms can't take categorical data. In such cases, you need to convert those categorical columns into numerical columns. Just like KNN, K-nearest neighbors, and regression models, all of those won't support mostly categorical data. That is when you will go for encoding. So in encoding, this is nothing but converting categorical into numerical. And numbers, categories, we will use encoding and we'll convert. In encoding also, we have different methods. We will see what is present. So one hot encoding. So what is this one hot encoding, everybody? So binary encoding or one hot encoding. Let us take an example for this. Okay, there is an example provided below. We'll see the example. So here if you observe, so this is your column. This is our column. So when you observe our column, there are 4 different categories present. Like what? One is high school, second one is bachelor, third one is master's, and doctorate. There is nothing new. So when we are converting categorical into numerical, all of these categories become individual columns. What is it? All of these become individual columns. So now high school, bachelor, master's, and doctorate. Now, wherever the high school is present, first we will go for this record. So high school is present here. So this is 1, remaining else is 0. And bachelor, this is present here. This is 1, remaining else is 0. High school is present here. Master's is present here. Doctorate is present here. Bachelor is present here. So that is how we will do one hot encoding. This is also called as binary encoding because we have zeros and ones. That is nothing but binary data. Okay, so when we have categorical data, when we have need like, we have to convert that categorical into numerical because some machine learning algorithms are not supporting categorical columns. That is when we have to go for this encoding. Within this, we have one hot encoding, which we have already seen in before example. When we are using that data, which is what is that data? When we have used that nominal to numerical, we have got zeros and ones. This is also an example of binary encoding. This we have seen in RapidMiner before. So now, one hot encoding is fine. Now, what about the other one? There is another one present, which is label encoding. So this is binary encoding. Now what? There is label encoding present. So what is this label encoding? So label encoding is nothing but, in order to perform this encoding, we should need some knowledge about this. But suppose you have 2 columns or 1 column. Imagine there is gender column. So within this gender column, we have a possibilities of 2 values, whether a male or a female. Whether you have, you will have a possibility of whether a male or a female. Okay, so in case of label encoding, what happens is, it will be checking in alphabetical manner. A, B, C, D, E, F, G, H, I, J, K, L, M. When you see M and F, so F is coming before, so this is taken as 1, this is taken as 2. This is label encoding. So in label encoding, again, there are of 2 types. One is nominal and second one is ordinal. So what is nominal and what is ordinal? So we already know about the data types. That is why we have data understanding beforehand to talk about all these data types. So nominal and ordinal. Nominal data is just like this. We don't have any specific order present. And here, when you go for this education level column, so high school, first we will go for high school, then we will do our bachelor's, then we will do our master's, then the doctorate. So this is the level. This is the ranking. So based on that, we will give the ranking. This is nothing but ordinal. Rank transformation or ordinal label encoding. So based on the order, we are giving this particular order in any new column. That is nothing but ordinal or rank transformation. This is nothing but label encoding. So one hot encoding is also called as binary encoding, and label encoding is also called as ordinal encoding. And what else is there? There is also attribute construction. So here, if you see, if you have knowledge like how many years it will take to complete high school. So 10th is 10 years, imagine, and remaining 2 years high school. Or we will start from 3rd year onwards now. Imagine the 12 years we are doing high school and 16 bachelors. And for masters, 2 years, again, that is 18. And when we add again 3 more years, we will complete our doctorate. This is how we will just understand the data and we will just give these values according to these education level column. So based on the data which is already present, we are creating a new attribute. So this is called as attribute construction. This is called as attribute construction. So we have seen encoding, what is binary encoding, what is ordinal encoding, and what is attribute construction. So let me delete this. So this is rank transformation. And here attribute construction is present. This is the attribute construction. And apart from this, you also have dummy variable creations and all. You can go through this. This is just like this one. If you have n levels in your data, what is n levels? Okay, let me tell you. Okay, for suppose there is a column which we have taken before, which is gender. Gender column have possibility of only 2 values. It may be either male or female, but it can't be any other thing, right? So whenever a column is having the possibility of limited values, when there is a possibility of having limited values, then that column is called as a factor. When there is a column present and there is a limited values present in that column, that is called as a factor. And whatever the values present, those are called as levels. So there are 2 levels here. One is male and one is female. Now, what is this about? So you have dummy variable creation. You have a concept of dummy variable creation. This is just like one hot encoding. So dummy variable creation, how can we talk about this? When you have n levels for a factor, for a column, when you have n levels, then you will create n-1 dummy variable creations, which is dummy columns. This is what the concept of dummy variables is. And there is one more thing, which is lexicographic encoding and all. So that means instead of going for the first letter and giving the value like this, just like label encoding I told you, it will just check all the letters. That is nothing but lexicographic. So these are the different encodings present. I hope this is clear. Discretization and encoding. So discretization is converting numerical into categorical, and encoding is converting categorical into numerical. Now let's see what is present next. Next, we have feature engineering. So what is feature engineering? Features, I already talked about this. Features are nothing but columns or variables or attributes. So when we are changing or making changes to that particular features or attributes, such concept is called as feature engineering. So here we have talked about before attribute construction. Based on the data which is already present, we are adding a new column to the data set, which is nothing but changing some, like making changes to the features or columns. That is feature engineering. And there is a few examples given here. Let us talk about one of these. For example, you have credit card example, right? So you have credit card over here. For this credit card, for suppose you have an output variable Y. So whether the credit card user is fraud or not fraud, we have to understand. Okay, whether the credit card user is fraud or not fraud, we have to understand. Okay, so for this, we have the data. I will talk about this a credit card example. I won't give you, like, you can understand the remaining things. Okay, so in this credit card example, you may have the output variable Y, which talks about whether the user is fraud or not fraud. And you may have the input variables like X1. This talks about the place where the previous transaction was made. Place of, okay, I will write it over here. So credit card, there is an output variable Y. It talks about fraud or not fraud. And then there is X1 variable. This is talking about the place of previous transaction. Place of previous transaction. Then there is another variable X2. This talks about the place of next transaction or the current transaction. And then X3 is there. This talks about the time of previous transaction. There are a lot of different data present. Time of current transaction. So based on this data which is already present, so for suppose you have these two columns. So based on these two columns, I can just create distance column. Distance is nothing but the difference between the two places where I've made the transactions. I can create a time log based on these two columns. So we are using the columns which are already present, like features or columns, whatever we call it as. We are adding a new more column, which is nothing but distance or time log. There we have added the years of education in the previous example. That is called as feature engineering or attribute construction. So this is about feature engineering or attribute construction. So now let's see what is present. What else is present? So the next important one we have is missing values. So what is this missing values about? So missing values, there are three variants of missing values. First one is missing completely at random. So when you see here, there is a small nice example given over here. So here if you see, this data, like for suppose this doctor is entering the details of patients. Okay, so when one patient came at first, he entered his name, age, gender, as well as whether he smokes or not. When after that, there are a lot of people coming at the same time, a lot of patients coming at the same time. So because of this, he may sometimes forgot to mention some details of some patient. Like here, for the third patient, he did not mention gender. He did not mention age. Just like that, he missed a few data in that entry while entering. So this concept is called as missing completely at random, which means here the cause at which the data is missing is not known. So this is in the form of this example. This is theoretical. Okay, the cause at which the data is missing is not known. We don't know exactly why the data is missing. We don't know the reason correctly. That is nothing but missing completely at random. Now, what is there? The second variant. So it may be missing because missing at random. So what is missing at random? So if you see here, this example, here, the same example, the doctor is filling the details of the patients. So first of all, a patient came who is wearing a sari. So he asked her whether she smokes or not. So she just gave a smile over here and she didn't answer anything. So he got confused like whether she smokes or not. Maybe she felt embarrassed. That's why she didn't say the answer. He may think any of the reason may be possible. So here, when there is a second variant which is missing at random, the cause at which the data is missing is known with uncertainty. We know the reason, but we don't know the exact reason. Is known with uncertainty. So the cause at which the data is missing is not known, that is missing completely at random. The cause is known with uncertainty, that is missing at random. And what is the next one? What is the next one present? So the next one is missing not at random. So what is missing not at random? If you see this third example coming over here, there is the community present. So within this community, maybe there is a rule like you should not talk about any habits like smoking or drinking or something like that. So this particular doctor knows about the rule, and that is why he did not ask the question and directly he entered NA. Okay, so in this missing not at random, here what we can call it as the cause is certain. We know the cause, and also what is certain? The cause is certain over here. So these are the three variants of missing values present. First one is missing completely at random, which is the cause at which the data is missing is not known, and missing at random, the cause is known with uncertainty, and missing not at random, the cause is certain. So these are the three variants present. Let me delete or clear these things. So these are the three variants present. So if you have missing values in your data, how you have to handle those missing values? If you have missing values in your data, how you can handle those missing values? So check it out. Okay, let me just move on to the next slide. So when you have missing values, you can simply go for deletion methods. So under the deletion methods, you have simple strategies. So first we will talk about the case-wise deletion. So case-wise deletion is nothing but, if you see here the data set sample provided under here, so there are missing values in specific columns. So when you have like a missing values in a specific column, in this case-wise deletion or list-wise deletion or complete case analysis, we will delete this entire record. Just like this. But in case of pairwise deletion or available case analysis, we will just go for correlation between the columns. Based on the correlation results, we will remove the columns or records. This is what pairwise deletion and case-wise deletion. So let me show you. I'll just clear these things. So case-wise deletion is you will delete the entire record. Pairwise deletion is we will go for correlation between the columns and we will go for these things. So correlation, pairwise deletion, and then accordingly you will delete the record. Now what else? So there are various imputation methods also present. So simple imputation methods. Instead of deleting the records or deleting the missing values, what else you can do? You can just replace those values with something else. That is where you will get the imputation methods. Imputation is nothing but replacing the missing value with some logical value. What is it? Missing, like a filling or replacing the missing value with some logical value is nothing but imputation. So when it comes to this imputation methods, you have a lot of imputation methods within which I'm just using statistical imputation. First of all, we'll talk about that. Mean, median, and mode. So what is mean, what is median, and what is mode? You already know about this when we are talking about measures of central tendency. So no need to explain this multiple times. Let's check the example. So if you see here, if you see in this data set, here, when we are about to calculate or check the missing values in age column, we are checking for age column. So in age column, there are missing values present. So these missing values, I have gone with mean imputation, which means I have calculated mean for age column. I've calculated mean, which is nothing but average of age column, and I got the output as 28 or something. And wherever the values which are missing in age column, I replaced it with mean value. That is called as mean imputation. So there are a lot of imputation methods present. Out of those, there is first one, statistical imputation present. So within that, we have age column in our sample data set. In that age column, there are few missing values present. And I've calculated the mean for this entire column. And I replaced this with this mean value, which is 28. And now next, gender. Gender is 1 and 0, zeros and ones, which is binary. So 0 means male and 1 means female. Imagine. Okay. So when you have such type of data, what you can go for? You can go for mode. Because whatever the most times which is repeating, for suppose if you imagine, here we can see most of them are zeros instead of ones. So we will replace the missing value in that column with mode. This is called as mode imputation. So we have already talked about when to go for mean, when do you go for mode, and when do you go for median. So in the last column income, you have one extreme value present, which is outlier. So when you have outliers in your data, instead of going for mean imputation, you should go for median imputation. That is why I have calculated median over here. This is the simple statistical imputation methods present. One is mean, second one is median, and third one is mode. So based on the column that you are working with, if that column is having extreme values or outliers, then you have to go for the imputation technique, which is median imputation. And if your column is not having any outliers present, you can go for mean imputation. And if you have categorical data, then you can go for mode. Anything is fine. These are the simple imputation methods present. Okay, and then what else? What else is there? I'll just go over here. Now, random imputation. So random imputation is nothing but when we are working with random imputation, we will just calculate for a particular column what is the minimum value and maximum value. So we will calculate what is the minimum and what is the maximum. So in between, for suppose minimum is 10, maximum is 40. So I can select some random number. Any number is fine, but it should be in this specific range. So select the random number and replace the missing values with this random number. That is called as random imputation. So statistical imputation consists of mean, median, mode. So I have told you when do you have to use which type of imputation based on the data. And the second one you have is random imputation. When you want to work with random imputation, you have to first find out the minimum and maximum. Based on that, you have to select randomly one value and you have to go for random imputation. And what is the next one? Next one you have is hot deck imputation. So hot deck imputation is nothing but, for suppose, if you have found a missing value over here. So in the fourth record, we have missing value. Then what we do when we are going for hot deck imputation, we will search all records wherever the columns values of this particular record is matching or not. For suppose, imagine this is 3120. This is present over here. So this is one, this is one. So imagine I have all these values which is matching with the fourth record. So what it does in hot deck imputation, whenever I found a match according to the record, wherever the missing value is present, this value present in that column will get replaced with the missing value. That is called as hot deck imputation. When you have two matching records, it will take the average. When you have no matching records, then that is some other kind of thing. This is nothing but hot deck imputation. So hot deck imputation, whenever we are working with this type of imputation, it will just search for the records which are matching with the record having missing values. If it is finding any record which is matching, then it will replace that value. If it is having multiple records matching, then it will take the average. If there is no record matching, then what it does is it will remove one by one the columns and it will check. Like if we remove income column, then it will check the matching with the other records. And even if the match is not found, then I will remove one more column and I'll check. I will remove one more column and check. That is how hot deck imputation works. These are the most used imputation techniques. And there are others also present: regression imputation, KNN, iteration, and multivariate imputation by chained equations. So these are all used in predictive models. So this is about missing values. So let us talk about the missing values. There are three variants. So missing completely at random, missing at random, missing not at random. So these are the three variants present. And when you have missing values present in your data, you can go for either list-wise deletion or pair-wise deletion, or you can go for imputational methods like statistical imputation like mean, median, mode, or random imputation, or hot deck imputation, or all the other predictive models. So let us see the same thing in RapidMiner. Just let me open my RapidMiner. So in this RapidMiner, I want to show you missing values, right? Remaining everything we have discussed, I'll delete this. So for this missing values, I will use any data and I will use the operator replace missing values. But there is no data for me which is having the missing values. So what I do is, I'll open any data. One is present. So education is present, no? So I'll just copy a few records of data. I'll copy this. I'll paste it in new workbook. And I want to have few missing values. So I'll sell it. Okay, we have missing values present in our data. Now I'll just save this. Missing values. That's it. Now, I've got a data set which is having missing values because the sample superstore, all those things which we use, those are not having any missing values. Okay, now I'll go to my RapidMiner. That is an Excel file. So I will use read Excel. I will use read Excel. I'll just drag and drop it, double click on it. Now I will just use MV dataset, which is missing values. And check this is okay. And next again, I don't want to format integer. So question marks are coming in place of these null values and finish it. So now I got the data which is having missing values. Let's check it. So this is the data having missing values. Now we will see how to replace those missing values. Now, in the operator section, you have a lot of different operators for missing values. So see, I want to replace my missing values. So whenever I want to replace, if I want to go for median imputation, I have to select average, minimum, maximum, according to the selection that it will do. So I want to work based on single column, which is which column that is present? Let me check. It is present in workx. So I'll just workx. I'll write it as workx. Workx is done. Now I'll execute this one. So now see, in the work experience, wherever the missing values are present, those are replaced with the median value. This is nothing but the imputation that you can do simply in RapidMiner. So what did we discuss? There are a lot of imputational techniques present. You can go for remove also. There are a lot of different operators present. So I will go for this missing. Let me just show you. So missing, replace, impute, declare, replace, remove. All of these are present. You can use whatever you want. Okay, I've shown you one example. So whenever I have data with missing values, I can just go for different types of imputation. I have shown you median imputation. And within this, I don't have any missing values right now in this column because those got replaced with median value. This is how you will do median imputation in DataMiner. Now let's see what is the other thing which is present in the PPT. Okay, this missing values is done. Now data transformation. So what is data transformation? Transformations are used to pre-process the data. Commonly transformations, why do we go for transformations? These are used to pre-process the data. And also it is used to make the data more suitable for analysis and also to improve the performance to build or increase the performance of machine learning models. So transformation is basically or commonly used to pre-process the data. So it makes it more suitable for analysis and also it will improve the performance of machine learning models. That is about transformation, and transformations is of different types. So when you have data, like what? Let me just show it to you. So we are talking about, data transformations. First of all, we have log transformation and exponential transformation. So you already know about how a curve will look when you have log and exponential. So for suppose there is a like a plot like this. There is a plot like this. So here, if you have a curve like this, like there is a minimal increase and there is a high increase over here. There is a high change. So this is called as exponential curve. This is called as exponential curve. When you have exponential curve type of data, you have to go for log transformation. And reverse. When you have log kind of data, log is nothing but reverse. This one. Oh, sorry. When you have your curve looking like this, so there is a, first of all, we have just a slight increase and a rapid increase. When you have such type of situation, that is called logarithmic curve. When you have it, we have to go for exponential transformation. So log transformation for exponential, exponential transformation for log. This is simple manner. Transformation is basically commonly used to pre-process the data to make the data more suitable for analysis process and also to improve the performance of machine learning models. And also we have other different types of transformation methods. Like first we have power transformation like x square, x cube, all those things, powers. If you are having x square, that is called square root or square. If you have cube, that is called cube transformation. If you have polynomial means what? What is polynomial distribution? You already know about polynomial distribution. But suppose if you have a curve like this with one bend. So if you have one bend, what is this called? This is called as polynomial with 2 degrees. When you have one bend, that is called 2 degrees. When you have two bends, that is called 3 degrees. Like if you have like this. So there is one bend over here and one bend over here. So two bends are present. So what is this called? This is called as polynomial with 3 degrees. Okay, when you are having n bends, bends is nothing but number of peaks plus number of troughs. You already know about peaks and troughs. Okay, when you have n bends, it is called as polynomial with n plus 1 degrees. So when you have such type of transformation, then it is called as polynomial transformation. Like for this, it is x and x square. And for this is x square and x cube. So for this type of data, that is called as polynomial distribution. Okay, log transformation, exponential transformation, power transformation, which is square and cube, and polynomial transformation. Reciprocally, you already know. So instead of taking x, we will take 1 by x. Reciprocal. That is reciprocal transformation. And what else? What else are there? So this is one. And box Cox. So what is box Cox? Box Cox and also Yo-Johnson's two methods are present. And what is the use of box Cox? Okay. So when you have, just a second. Okay. So when you have, here if you observe, when you have positive values, when the values that you're working are positive, then you can go for box Cox. But when you have positive, negative, and 0 values also, you can't go for box Cox transformation. Instead, you can go for Geo-Johnson's transformation. Here, there will be change in lambda, which is the power. So box Cox transformation and Geo-Johnson's, when there are positive values, then you can go for box Cox. When you have positive, 0, and negative, you can go for Geo-Johnson's. You can go through all these transformation techniques in the mind map also. So this is about data transformation. Transformation is basically commonly used to pre-process the data. And whenever you have positive values, you can go for box Cox. If you can go for power, square, cube, log, exponential based on the data that you're working. This is about data transformation. And what else is present next? So next we have data scaling. So data scaling, we have different methods. What are the different methods present? Which is normalization, min-max scalar method or range method. Anything is fine. Now let's see what is normalization first. What is normalization? So scaling is nothing but we will just convert the data scalars or unit tests. You will have something, right? So we will just go to the mind map and check up to where we have discussed. I'll just okay, let me go to the mind map. We have discussed up to the 4 business movements and also graphical representation. Let's see data preparation or data cleansing. This one. So here we have discussed typecasting, the change of data type. Handling duplicates is fine. Outlier analysis, we have variance, which is 3 variants and also different techniques, and also zero and non-zero features. So usually we ignore the columns which have the same values. That is nothing but zero, non-zero. Discretization, binning or grouping, converting numerical data into categorical. And then dummy variable creation, we have seen n-bends, one-hot encoding, label encoding. All these are techniques of dummy variable creation. And missing values. Missing values imputations are present. And here we have 3 variants and also different techniques. Deletion method, simple imputation, model based. Next, we have transformations. We have seen different types of transformations. Box Cox, if you see here, Box Cox is based on lambda value. So based on the lambda value, it will just gives you the output. So see whether you have to use log transformation or square root, it will talk about with the help of lambda in Box Cox, but it will take only positives. If you want to go for Johansson, it will just gives you based on lambda value itself, but here we can take the positive, negative, and zero values as well. This is about transformation. Now we are talking about feature scaling or feature shrinking or data scaling. So it will make the data scale free and unitless. So there are 3 methods. We will see each one of them. So this is done, this one. So the first one is normalization. What is normalization? So everybody, what is normalization and what is standardization? What is robust scaling? First, we will look into that and then we'll move on to the formulas. First one is normalization. So normalization or min-max scalar method or range method. So this is nothing but this technique scales the data to a range between 0 and 1. So normalization, you have normalization, normalize operator present in DataMiner with which you can perform normalization, within which you can select the range method as well. Okay, so apart from that, we are discussing about the normalization. Normalization is the technique which scales the data to range between 0 and 1. So it is useful when the distribution of data does not follow Gaussian distribution. That is, if the data is not normally distributed, then you can go for this normalization technique. Okay, normalization is like beneficial for some types of algorithms like k-nearest neighbors, KNN, and neural networks, etc. So normalization is nothing but this scales the data to a range between 0 and 1, and then this is used when the data is not normally distributed or whenever the data is not following Gaussian distribution. And this is useful for some algorithms like k-nearest neighbors and neural networks. This is nothing but normalization. It is also called as min-max scalar method or range method. So why this is called range method? Because range is nothing but minimum minus maximum or maximum minus minimum, right? The difference between maximum and minimum, you can see it in the formula itself. So range method, x minus minimum by max minus minimum. This is range. So this normalization is called as min-max scalar method or range method. And what else? So there is second one, which is standardization. So standardization, we already talked about this. So standardization transforms the data to have a mean of 0. It will transform the data to have a mean of 0 and standard deviation of 1. Before we talked about when we have normal distribution data, when we standardize this, the mean is converted into 0 and the range is between minus 3.4 to plus 3.4. So when we are doing the standardization scaling method, it will transform the data where the mean will be 0 and standard deviation will be 1. So this is used when the data is following Gaussian distribution, which means the data is normal. So this is based on mean and standard deviation. Here the mean is 0. So when we compare the normalization with standardization, standardization is less affected by outliers when compared with normalization. This is less affected. Okay, so this is about the second one, standardization. So normalization is a technique in which we scale the data around or between 0 and 1. It is useful when the distribution is not following Gaussian distribution. When the data is not normally distributed, you can go for normalization. The formula for that is x minus minimum by max minus minimum. It is also called as range method or min-max scalar method. And the next one we have is standardization. Standardization is nothing but transforming the data to have a mean of 0 and standard deviation of 1. So it is effective when the data is following Gaussian distribution, which is normal distribution. So when compared with normalization, standardization is less affected by outliers. So these are the two scaling techniques, and there is one more. That is robot scaling. So what is robot scaling? What is robot scaling? Robot scaling scales the data based on percentiles. Robot scaling scales the data based on percentiles. It will make it robust to the outliers. So it is suitable for the it is suitable when the data set is having outliers or when the distribution is skewed. Why we are talking like when the data is having outliers? Because robot scaling is based on median. So median is not affected by outliers and IQ are nothing but percentiles. So robot scaling, it is for standardizing, or it is for scaling the data based on percentiles, making it robust to the outliers. So this is mostly preferred when the data set is having outliers and when the distribution is skewed. So it is robust scaling is achieved by subtracting median and dividing by interquartile range. So depending upon your data, you can go for whatever the method that you want. So if your data is not normally distributed, you can go for normalization. If your data is normally distributed, then you can go for standardization. If your data is having most outliers, you can go for robust scaling. So depending upon whatever that you have or whatever the data that you have, you can go for different types of scaling techniques present over here. So we have seen normalize in RapidMiner as well before, right? Let me show you one more time what are the operators present. So I'll go to RapidMiner. So here, I'll just click on normalize. Sorry. So see, I've shown you this normalization before, right? In the education data set. So this is nothing but normalization, denormalization. You can work on whatever you want. Okay, when I just take this one, normalize, I can select the attribute. I want to normalize which data is present. This one is sample superstore, no? Sales. Oh, there is no sales here. We'll go for GMAT. So see, this is nothing but data normalization, which converted the values over here. Okay, this is how you can use the operators drag and drop, and you can just achieve the output by using RapidMiner. Okay, you can just scale by bytes. You can go for whatever the technique that you want. And also normalize series, different types of transformations. You can check out all these operators. Okay, now let's go back to the PPT and check what is present. So we are done with missing values, data transformations, and data scaling. Now, next one that we have is feature selection. So what is this feature selection? So feature selection techniques, feature is nothing but attributes or columns that we talked about before. So feature selection techniques will help in reducing the dimensionality of a data set. Okay, it is used in reducing the dimensionality of a data set. How it is going to reduce? By selecting the most relevant features while removing the irrelevant features. Like we have told, feature selection is nothing but whatever the columns that are unnecessary, we are going to remove them. Irrelevant or unnecessary, anything is fine. So feature selection technique will help in reducing the dimensionality of the data set by selecting the columns or the features which are relevant while discarding the features which are irrelevant. So in order to perform this feature scaling, we have different types of methods present. What are those methods? First one we have is intrinsic feature selection. So what is this intrinsic feature selection? So here, this is performed automatically by certain algorithms like decision trees, etc., which will inherently select the features based on the importance during model building. So there are different methods to perform this feature selection. First one is intrinsic auto feature selection or intrinsic feature selection, anything is fine. So here, this is performed automatically by certain algorithms like decision trees. In here, the feature selection is done which selects inherently they will select whatever the columns are important during the model building. That is nothing but intrinsic feature selection. And then we have filter methods. So filter methods is present over here as well in RapidMiner. In operators, filter examples are present. So see here. When we check this one, filter examples and filter example range. So you can add the filters. You can just perform whatever you want, okay? This is nothing but filter. I forgot to show you beforehand. That is filter. And if you want to select only few columns, you can go for select attributes. And if you want to just get all the information, statistical information, you can go for extract attributes. You can use all the operators. You can understand what is the purpose of each and every operator, and you can work on it. Okay, we are talking about the methods of feature selection. The second one that we have is filter methods. So filter methods, they will establish the relationship between the input columns or the input features and the target variables. So it involves some of the machine learning algorithms. So examples, some of the examples of this filter methods includes statistical based feature selection and hypothesis testing. So statistical based methods, it utilizes what is the statistical based methods means? So basically, they utilize statistical metrics to evaluate the relationship between the features, the input features, and the target variable. So what is this? This is another method, which is filter method. Filter method talks about, filter method is used to establish the relationship between the input features and the target variables. So within this, again, we have statistical based feature selection. Here, the statistical metrics are used in order to evaluate the relationship between input features and target variables. So within this, we have correlation coefficient. So correlation coefficient, you already know, it measures the linear relationship between numerical features and the target variable. And then mutual information, it measures the amount of information gained about one variable through the other, which is applicable to both categorical as well as numerical features. What is the mutual information about? It is applicable to both categorical as well as numerical columns or numerical features. This measures the amount of information gained about one variable through another variable. That is mutual information. And coming to hypothesis testing. So hypothesis testing, here we have again chi-square test and ANOVA test. And chi-square test here, it assesses the independence between categorical features and target variable. Categorical and target. And then here this is applicable for numeric features and target. So it evaluates the variance. It evaluates the variance. What is this? What we have spoken up to now. So feature selection, it helps in reducing the dimensionality of a data set. How? By selecting most relevant features. By selecting most relevant features, whereas whatever the features that are irrelevant, we will discard those features. That is irrelevant are discarded. So this is how feature selection is done. So there are different methods present under that. First one is intrinsic feature selection. Within this, it is performed automatically by using some machine learning algorithms like decision trees. Here, they inherently select some feature based on the importance during the model building, and they will decide whether to keep it or discard it. And second one we have is filter methods. Filter methods, what is filter methods? Filter methods establishes a relationship between input features and target variables using some machine learning algorithms, within which we have again few more statistical based. Here, based on statistical metrics, we will decide the relationship. First one is correlation coefficient. This talks about the linear relationship between numerical features and the target variable. Mutual information, it measures the amount of information gained about one variable from the other. It is applicable to both categorical and numerical. And coming to the hypothesis testing, it consists of again chi-squared and ANOVA. This assesses the independence between categorical variables or features. So this talks about the variance between numerical features and target variable. This is about a few methods present under filter methods technique. And the last one, the third one that we have is iterative feature selection. What is this one? So this involves repeatedly building the models with different subsets of features. Iterative means repeatedly. So it involves repeatedly building the models It involves repeatedly building the models by using the subset of data. With different subsets of data, we can write it as. So repeatedly building models with different subsets of data. Or columns or features, anything is fine. Okay, with the help of different subsets of features, we are repeatedly building the models, and from that, we will yield best performance. From that models, we will yield the best performance. This is about iterative feature selection. So feature selection, basically, it is helping to reduce the dimensionality of the data set by selecting the most relevant features and discarding the irrelevant features. So there are different techniques involved: intrinsic feature selection, statistical based feature selection, iterative feature selection. So there are different techniques present. You can go through these. And what else? The next one that we have is some other methods. What are some other methods present? Wrapper methods. So wrapper methods like recursive feature elimination, these are used to select features by recursively considering smaller and smaller set of features. What is this one? So there are few other methods for feature selection. Wrapper methods and feature importance scores. We won't talk about these much. Decision tree, random forest variable, you already know about this. These are also present by default in RapidMiner. I'll show you the operators as well. Okay. So recursive feature elimination. This method starts with all the features, which means all columns, and then it recursively removes the least important feature. So out of all the columns which is least important, that it will remove. Elimination. So remove recursively the least important feature. Okay. Until when it will remove? Until the desired number of features is reached. Until desired number of features is reached. This is about recursive feature elimination. So it will just start with all the features, and recursively it will start removing the least important feature until the desired number of feature is reached. Until the desired number of features is reached. That is nothing but recursive feature elimination. And then we have one more thing, which is feature importance scores. So within this, we have regression coefficient values, decision tree, random forest variable importance score, and permutation importance. So these are the different other techniques for feature scaling. Okay. Okay. So feature importance scores. Coming to that, we have regression coefficient values. So regression coefficient values for these linear regression models, what happens? Larger the absolute values of coefficients will indicate important feature. So if the absolute value of a feature, is larger, that indicate that feature is most important. So according to this regression coefficient values, the bigger the better. So which means for linear regression models, the larger the absolute value of a particular feature or a coefficient will indicate that is the most important feature. And second one we have is decision tree. We'll just remove this one. Next one we have is decision tree information gain. So decision tree, what it does, it will, as it is a tree, it will split the nodes based on a feature with the highest information gain, which indicates feature importance. So it will just split the nodes based on features. It will split the nodes based on features with the highest information gain. That is called decision tree information gain. So what is this? Decision tree information gain. It splits the nodes based on features with highest information gain, which indicates the feature importance. That is nothing but the feature importance scores. So here, the absolute value, if the absolute value of a coefficient is bigger or larger, the importance is higher. Here, the highest information gain, that is nothing but the important feature. And random forest variable importance score. So what is this one? So random forest, what it does, it measures the decrease in model performance. This measures what it does, this random forest variable importance course, it measures the decrease in, it measures the decrease in model performance. Okay, when it is going to measure the decrease in model performance when a feature is removed. So when we are removing a column or a feature, so we will check whether the performance is getting reduced or not. Based on that, we will see how much important that particular feature is. So feature importance scores, how can we calculate the importance of features based on different models? First one is regression coefficient. So regression coefficient, this for linear regression models, whatever the coefficient having the larger absolute value, that is having the bigger importance. And decision tree, so it will split the nodes based on features with highest information gain, which talks about the feature importance. And random forest variable importance score, here, random forest measures the decrease in model performance whenever we remove a feature, whenever a feature is removed. Whenever a feature is removed. So that is when we can understand how much important that particular feature is. And the last one is permutation importance. So the technique measures the decrease in model performance when the values of a feature are randomly shuffled. So here permutation is shuffling. So here importance scores, this is by removing. So here it measures the decrease in the model performance when the value of a feature is shuffled. That is how we can understand the importance of a feature in permutation concept. So these are the different methods present for feature selection and also different feature importance scores. And what else? And what else is there? We will check it out. What else is present? So that is it. We have gone came to the end of this particular module. So what we have seen in this module, let's just recap this module. And I will show you what are all the methods present. Feature selection rate. We have seen decision trees and all. Let me open the RapidMiner and I will show it to you. So see, decision tree, random forest, all of these things, everything you can perform here as well in the RapidMiner. Okay, you have to get a knowledge of what is the purpose of each and every operator, way to use them and get the output. That is what you have to understand. And coming to the PPT back. So, sorry. Here we have talked about different data preprocessing steps present. First one we have is this one, which is data cleansing and organizing. And we have to clean the data. And if it is not structured, we have to structure the data. And then what? We have to change the data type according to our requirement. That is called typecasting. And if there are duplicate records present, we have to handle the duplicates. We have seen every step in RapidMiner as well. And then what? Outlier analysis, it is based on 3R technique, whether you have to rectify the outliers or retain the outliers or remove the outliers, whether you have to go for percentiles by using winsorization technique and replace the missing values, replace the outliers, and whether you have to go for alpha value and trim the outliers. You have to understand what you want to go for. And whether you can also go for standard deviation approach, IQR method, and other predictive models as well. And zero variance features. So whenever a column is having the same value that is not mostly required for our analysis process, we can remove that column. So when it is categorical, that is fine. When it is numerical, you can go for variance. That is called as variance. That is called as zero and near zero variance features. And then what? Next, we have discretization and encoding. So discretization is converting numerical data into categorical data. So some of the machine learning algorithms like decision trees expect your data to be categorical. That is when you will have a requirement like converting numerical columns or numerical values into categorical values. So you are applying a few rules over here, just like this one, and you are converting this number into categorical value. And after that, if you are applying the rules to convert these categories into 2, that is called as binarization. And coming to the rounding values may be floor or ceiling. Anything is fine. And binning is nothing but discretization. It is also called as grouping. If you have fixed bins, that is called fixed with binning. If it is not, it is called adaptive binning. And then we have encoding techniques. So encoding is nothing but the reverse of discretization. we can convert categorical into numerical by using encoding techniques. So some algorithms like some algorithms like KNN or regression models, they want, they mostly prefer numerical columns, numerical data instead of categorical data. So in such type of situation, you can go for encoding techniques to convert categorical into numerical. Here again, we have different techniques, which is binary encoding, which is also called as one-hot encoding. Here you can see whatever the category is present, that will become individual columns and converted into ones and zeros. And ordinal encoding, which consists of, it is also called as label, and it is of nominal and ordinal. This is we have discussed before. And also dummy variable creations we have discussed, and attribute construction also we have seen. And in this, I've told you an example of credit card. And feature engineering is whatever the changes that you are making in a feature, whatever, whether you are adding or deleting or updating, whatever that you are making, that is called as feature engineering. Next one is missing values. So missing values variance is of three types: missing completely at random, missing at random, and missing not at random. And also I've told you what is the techniques that you can do when you have missing values in your data. You can go for deletion methods, or you can go for simple strategies like case-wise deletion or pairwise deletion, or you can go for imputational methods like mean, median, mode, which we have seen in RapidMiner as well. And also we can go for random imputation, Hortec imputation, and other predictive models. And transformation is basically used to pre-process the data to make it more suitable for analysis process. So there are again different types of transformations involved here. You can go for whatever you want according to your requirement. And we have again the scaling techniques. So data scaling, it will make the data scale free and unitless. You have again three techniques present over here, which is normalization, which is also called min-max scalar method, and standardization and robust scaling. So normalization, this technique scales the data in between the range that is 0 and 1. So it is useful when the data is not normally distributed. That is, it is not following Gaussian distribution. Okay. And here, it may be useful for some algorithms like KNN and neural networks, all of those things. And then second, we have standardization. So standardization will transform the data to have a mean of 0 and standard deviation of 1. So when you have when the distribution of data is normal, then you can go for standardization, which we have seen before. And robust scaling, when you have outliers in your data, you can prefer robust scaling. So robust scaling, it will scale the data based on percentiles, making it robust to the outliers. So this is nothing but data scaling. And then we have feature selection. Feature selection will help to reduce the dimensionality of the data set by selecting whatever the columns or features which are relevant and discarding the features that are irrelevant. And we have seen all of these things. This is about the data pre-processing steps involved. So we have seen EDA, exploratory data analysis, the 4 business movements, and also we have seen the data pre-processing steps. Normally, what does that mean, and how we have to do in RapidMiner. We have seen all of those. Now let's see one example of supervised learning and one example of unsupervised learning. Let me open the RapidMiner. So I'll delete this one. Okay. Now let's discuss first of all what is supervised learning and what is unsupervised learning. Okay. So first suppose, okay, let us talk about the example later. So supervised learning and unsupervised learning. Sorry. Okay. Supervised learning and unsupervised learning. So supervised learning, in supervised learning, the algorithm learns from labeled data. The algorithm learns from labeled data where the training data set includes both input features and target variables. So there will be training data set present. And first of all, this supervised learning is nothing but if you have output variable in your data, you will go for supervised learning algorithms. If you don't have output variable, you will go for unsupervised learning algorithms. So when you are going for supervised learning algorithm, it will learn from the labeled data, and also within the training data set, It includes both input features as well as target variables. Target tables, anything is fine. So the goal here is to learn a mapping from input features to the output labels. So we will see this in the form of an example over here as well. One example. So some of the examples here includes decision trees, regression, linear regression, support vector machines, everything is present. So basically supervised learning is nothing but when you have output variable present in your data, you will go for supervised learning algorithms. When you don't have output variables, you will go for unsupervised learning algorithms. So we will see one example of each. First of all, we'll talk about supervised learning. So let us take an example of supervised learning. So supervised learning, let us say we have a data set present. So there is a data set which is having information about houses like what is the square feet of a house, the size of a house, and what is the price of the house. Okay, so I have a data set present. Okay, sorry, I'll just. So I have a data set. Within this, I have two columns. One is what is the square feet size of a particular house and what is its price. Okay, I have two. So my task is to build a model that can predict the price of a house whenever a particular size is given. What is it? I want to predict the price of the house. I want to predict the price of a house whenever a certain size or a square foot size of a house is given. Okay, so this is the regression problem because we have output variable, we have input variable. Based on this, we have to predict this. So we have to obviously go for supervised learning algorithms. Okay, now based on this, we have to go for whatever the algorithm that you want, either linear regression or whatever you want. And then you will have to train the data, you have to predict. Those all steps are involved in this particular supervised learning. In order to do this algorithms in this particular RapidMiner, you don't need to learn everything because we don't have to write the code in this. We just have to use the operator properly. And coming to the unsupervised learning. What is unsupervised learning? Unsupervised learning, we don't have any output variable. It will learn from unlabeled data. And also, input features are provided, only input features are present, output features or labels are not present. So here, the goal is to uncover the patterns or structures or relationships, whatever it is, the clustering algorithms like k-means clustering, this all comes under unsupervised learning. So unsupervised learning, we don't have any output variable. Here, the main goal is to uncover the hidden patterns, structures, or relationships in data. So here, some of the algorithms includes k-means, dimensionality reduction techniques like PCA, everything is present. So let us see an example for everything right now in this, for each one of the supervised learning and unsupervised learning. So, okay, first let's look at KNN K nearest neighbors algorithm. How to use it? So you don't need to just learn everything of it. You can just use the operator, which is KNN. So KNN operator is present, you can use it. So before doing that, I have to use a data source. So you already know about the iris data set, right? Let me open that and show it to you first. Okay, let me open the iris data set. Just give it a second. So here I'm going to show you one of the algorithm which is KNN. Just a second. Is that exactly? Yeah, Fisher's iris data. This is a CSV file. Just give it a second. Okay, this is our fishes iris data, simply iris data. You have here information about flowers. So what is the petal length? What is the width? What is the length? What is the width? And what is the species? You have all this information. Let me close this and let me just explain one of the supervised learning algorithm, which is KNN, K nearest neighbors. So we'll go to here and I will use, this is a CSV file. So I'm going to use read CSV. So I'll just use this one, read CSV, and I'll double click on it. And I will select my data set. If you want to change your format or your column data types, you can change it. I don't want to change anything. So I've got my data over here. If you want to see, just make a connection and execute it. Just a second. Now I will execute this one. Now I'll get the output. Okay. If you want to do the statistics, you can go and see the statistics as well. So we don't have any missing values in our data and we have these range of values. Now I'll go back to my design. Okay, I got my data set. Now in order to perform KNN, what you have to do? You have to first use one operator, which is set rule. So let me click on it. So here you have set role. What is the purpose of this one? So let me show you. So set role. So here I will set the role of species. So see, I will set the role of species as label. Species as label. Target role, regular, batch, cluster, I will take it as label. Okay. I have just given a role for this. I've set the role of species to label. Now I'll click on apply. So I've set a role over here. Now I have to perform K nearest neighbors. The algorithm, which is K nearest neighbors. So I'll just apply this algorithm. So before doing this, you have to give how many neighbors you want the K value. So before doing this, you have to give the cross validation. Cross validation, because we have to have training set and the model set rate. So here we will go and give cross validation. So cross validation, I'll take it over here and I'll cut it. This one I'll remove. Okay. This one I'll remove. In place of it, I'll keep the cross validation. So what did I do? I've just loaded my data and then I've set a role which is species is equal to label. And then I've created KNN, but I did not create anything because first I want to have cross validation. After that, I'll just give this output of set role to this cross validation as input. Now I'll double click on this. Once I double click on this, just a second, I will get here training and testing phase. So now you have to give in the training KNN algorithm. So you have to just establish the connection and you have to establish the connection between mod and mod as well. Model. Okay, now what you have to do in case of testing. So in case of testing, you have to apply the operator, which is apply model. You have to apply the operator, apply model. So take this apply model and leave it here. Now establish the connection between again these two. After applying the model, we have to get the performance. That is the main theme, right? Now we will check the performance using performance execute. So I'll just remove this. I will just do with the help of I don't have this. So you have to measure the performance over here by applying the model. So I'll check whatever that I want to apply. everything is fine. I'll apply over here. So we have to establish the correction over here as well. In this one. First of all, you have to load the data. I have used here iris dataset, which you're already familiar with. Now, I'm going to just establish the relationship over here and for this as well. And the performance, you have to measure the performance. In order to measure the performance, you can go for different types of operators present over here. But for this, which one? This is KNN, which is K nearest neighbors. This is supervised learning algorithm. Why this is supervised? Because we have output variable present. We have output variable present. That is why we can call it as supervised learning algorithm. Now, if you try to execute it, just a second. This we did not establish it. This is missing. So the performance is the data-based performance. This is database performance. Average is 15. And this is KNN classification. Here, we have the model contains 150 examples with 4 dimensions. Okay, this is opening new process. I don't want new process. Just give it a second. Let us create one more time. So I don't have that data present. I'll just use read operator. Read CSV. Which is iris data I want. Just give me a second. Iris data. So I'll just load Fisher's iris data and next. Okay. Next. And a finish. After that, what you have to do? So after connecting with the file, you have to set a role. What did I do? I set a role. So before we have done something wrong. So I'll set a rule and I'll set it the species to label. The same thing that I'll do. So I did not execute it. That is why it is not giving me the output. So let me execute this table. Okay, let me go back to the design. No, I got it. Now set role. And I'm setting this to species, which is label and apply. And after that, I'm just going to give cross validation over here. After cross validation, I'll just double click on this. And here I have to give whatever the algorithm that I'm trying to do. That is KNN, K nearest neighbors. And I have to establish the connection between these two and also these two. And now I have to just use one more operator, which is apply model. Which is apply model. So this apply model goes into testing phase and I have to establish the connection modeling as well as testing. And I have to select the operator, which is performance and go for classification. So I'll go for this performance classification over here. Now I'll establish the connections again here. With this between these two and performance with this and exam with this too. Okay, now this is fine. Now we'll go back to the process and we will just establish the connection over here as well. Establish the connection here as well. Now click on execute. So check it. So every connection is present, CSV file, setting the role, cross-validation. And when you double click on this, you have training and testing. So we have KNN, apply the model and performance. So here the input is missing. I've given the input now. Okay, fine. Okay, this is creating multiple classifications. Here's your accuracy. It is 96% accurate. So in order to find this accuracy, you can go for K nearest neighbors algorithm. So you just have to understand what you have to connect with which operator and all. So K nearest neighbors, how did I do? First of all, I'll just go back and I'll show it to you. Design view. So first of all, I'll just go back to the process. I've just used the data iris and I've set a role which is species is label and I've used cross-validation operator. So when you double click on that, you have training and testing. Within this training phase, I've used the algorithm KNN. And in the testing, I've used the operator, which is apply model. And to test the performance, how much accurate it is, I've used performance. Give the connections clearly and execute this process. After that, you will get how much accurate your result is, which is 96%, which is good. If not, you can change the K. You can change the K neighbor value and you can just execute again and see the accuracy. So this is about one of the algorithm, which is supervised algorithm, which is K nearest neighbors. So you can go for all such type of algorithms here. So this is about the RapidMiner, in which you have no-code development platform. This is a no-code development platform which have drag and drop interface. You don't need to do anything, just you can drag and drop the operators without writing the code and get the output. You can just work on non-supervised learning as well. So non-supervised learning, we have K-means clustering. All of those are present. So you can check it out. Maybe I'll show you one more example. See. Okay, I'll again use the iris dataset again. That is read CSV. So here I will just connect with iris dataset, which is Fisher's iris. Okay, I'm not changing the data types. Now I will execute this one. Okay, I got the CSV data, which is iris data. So which is about the flower data. Now, if you want to normalize this data, you can normalize it. If you want to normalize the data, sorry. You can normalize it. I already told you how to normalize it, right? So normalize the data based on all columns or one column you have to give it. So I don't want to normalize. If you don't want to normalize, you can ignore. But if you want to normalize which column, for suppose, I'll go back here and I'll check the statistics. Okay, you can check whatever the columns that you want to normalize and you can give in the parameters, which is the customization of operators, and you can execute it. And you can use clustering operator to do K-means clustering and all. So see, K-means is present, you can do K-means and you can do the clustering. And also, after that, you can measure the performance using performance, which is performance clustering. Just yes. Where is this one? So you have cluster count performance, density performance, distance performance. We mostly go for distance performance. Anything is fine. So performance and measure it, you will get the performance. This is how you do K-means clustering. So KNN is an example of supervised learning and K-means is an example of unsupervised learning. So, okay. So this is how you can work on it, KNN, K-means, and also I've shown you before how to just pre-process your data by dragging and dropping. But you should, like, even we are not data scientists, but you should get the knowledge of what is what in order to use these operators. But if not, we may get confused and we may use the operators wrong and connections wrong. and we don't know the theory. If you don't know the theory, we can't apply it in the real time, right? Even dragging and dropping it is also not possible without learning. So the one easiest thing over here is you don't need to write the code. You can just use the operators and you can just perform all these models or build the models or whatever the algorithms, machine learning algorithms that you want to use, you can just use it with the help of drag and drop over here in RapidMiner. So these are all the things that you can do with the help of this particular tool, RapidMiner. So what we have seen overall, we have seen the RapidMiner, what is the purpose of it, and how we have to install, and what are the components present, and what is the purpose of each and every component, and what we have to perform while we are working on a project, which is project methodology, what are present, like business understanding, data preparation, and within data preparation, exploratory data analysis, and what are the data pre-processing steps. And after that, you have model building. You can go for supervised or unsupervised learning depending upon your data. Like, okay, unsupervised learning is nothing but if you don't have output variable in your data, you can go for unsupervised learning algorithms. If you have output variable and if you want to just predict something based on your data, you can go for supervised learning. So I've shown you KNN in, what is that? I have shown you K nearest neighbors in RapidMiner, how to do it. You can just explode those operators and you can work on it. So I hope this RapidMiner session is helpful for you. Thank you so much.